Good morning. So track 2. Hi, I'm good. How are you? Somebody is at home. So first year track 2 completed. Now first I am going to the small chapter, and weightage wise they are important also. So that's why I am starting with the EM wave first. Okay. So in the EM wave, first thing, what is the source of the electromagnetic wave? So this everybody knows. Source of the electromagnetic wave is what? Accelerated charge particle is the source of the electromagnetic wave. And the electromagnetic wave, electromagnetic, why we are calling it as electromagnetic? Because it contains the electric and magnetic field vector. Okay. Varying electric field produces magnetic field, varying magnetic field produces electric field. Like this way, electromagnetic wave propagate in the any medium or even in vacuum also, because electric field and magnetic field exists in vacuum also. Okay, that's why we say the electromagnetic wave can travel in vacuum also. Okay, because we are defining the permittivity and permeability of the vacuum or air also. Okay, so one thing, what is the source of the electromagnetic wave? Accelerated charge particle. In the exemplar, one question given, which will produce the electromagnetic wave, like a charge particle is moving with constant velocity, a charge particle is moving in performing uniform circular motion. So when constant velocity given, it means acceleration is 0, then it will not produce the electromagnetic wave. A charge particle performing uniform circular motion. Uniform circular motion means speed is constant, but velocity is continuously changing, so it will have the centripetal acceleration, then it can produce the electromagnetic wave. Okay. Next thing, concept of the displacement current. Okay, so why we have introduced the concept of the displacement current? What is the displacement current? So up to the current electricity, everywhere up to the magnetism also, we were always talking about the current. We were never using even the word conduction current. We are saying current. So that current we are taking as a conduction current because it is due to the flow of the charge. So when the current is due to the flow of the charge, it is a conduction current. What is that displacement current? Why we introduce it, and what is the meaning of that? So if suppose I am asking what is a magnetic field produced by, suppose I am taking one wire that is containing the current I. I am asking what is a magnetic field at a distance R from this wire. Then everybody know the Ampere's law. By the directly you mucked up the formula. But how we are taking the Ampere loop, circular Ampere loop like this. Then which point you want to find the magnetic field? Your loop has to pass from that point. Okay. So suppose I want to find the magnetic field at the point P. So I will take the circular Ampere loop, or I am considering the disk. Okay, Ampere surface I am considering the disk. Now this point I want to find the magnetic field. What is the Ampere law? B dot dl is equal to mu naught into I. Somebody is using I enclosed, somebody is taking what I is crossing the surface. Basically, what is the meaning of I? The I which is intersecting the surface. I which is intersecting the surface. So here, what is the current intersecting the surface? That is I. So right hand side we know mu naught into I. Left hand side is what? B dot dl. Magnetic field lines are what? Tangential to the surface. So B and dl angle we can take 0. So B dot dl, what we will get? B into 2 pi r. B into 2 pi r, that is equal to mu naught into I. From that you will get the B is equal to mu naught by 2 pi I by r. That formula you mucked up. Yes or no? So by this way we can find, when due to the current, we can find the magnetic field at any point. Okay. When we are doing the same in the capacitor, suppose capacitor we connected, capacitor plate we connected with the conducting wire. Okay. In the wire, which current we will have? Conduction current. Why? In the wire, charge is flowing or electron is flowing. So which current we have in the wire? Conduction current. Okay. So in this, suppose I am taking the, we want to find magnetic field here. So we have taken the circular Ampere loop. Okay, what I have done here. Everybody getting or not? I will apply the Ampere law, B into 2 pi R is equal to mu naught into I. How much current is crossing this Ampere loop? I. Then what the point P I will get? Mu naught upon 2 pi I by R. Okay. But one thing, magnetic field at any point will not depends upon what is the shape of the Ampere surface we are taking. Any shape we are taking. Otherwise, when we are mugging the formula mu naught upon 2 pi I by R, then we will say for this surface this is the magnetic field, for this surface this is the magnetic field. But we know that magnetic field due to the long wire at a distance R, current carrying wire, it is a mu naught by 2 pi I by R. So magnetic field will not change by changing the shape of the surface. Okay. So by that way they introduce the concept of the displacement current. Suppose I am finding the magnetic field at the point P. Okay. So due to the conduction current, what is the B I got? Mu naught upon 2 pi I by R. But suppose I am taking the Ampere loop. Like this is the this point I want to find the magnetic field. First I took the Ampere loop here like a disk. Then I got the magnetic field mu naught upon 2 pi I by R. Now what I am taking? Like a open pot. Okay, this is the shape of the Ampere surface I am taking. Okay, so what I said, magnetic field will not change with the shape of the Ampere surface. Now here, if I want to find the magnetic field at the point P, okay, then here current is not cutting, this current is not crossing the surface. I have taken the open pot. Open pot means current is not crossing the surface, current is not cutting the surface. Okay, so for this current I will not take, conduction current I will not take. But at this point, magnetic field, I know that it will not change with the shape of the surface. So this surface is passing between the plate of the capacitor. Okay. So it means some current has to be here. That current is cutting the surface inside the capacitor. The current is cutting the surface inside the capacitor. From here, this concept of the displacement current came. It means here magnetic field same. But here I have taken the open pot. Open pot means current, this I is not cutting this surface. Okay. Then here conduction current is not cutting the surface. I am going inside between the plate of the capacitor. Here surface is passing between the plate of a capacitor. Okay. It means some current has to be there which is cutting the surface. Which current will be there inside the or between the plate of the capacitor? It is we have given the concept of the displacement current. So we are saying between the plates of the capacitor we have the displacement current. In the conducting wire we have the conduction current. Okay. What is the origin of the displacement current? What is the reason of the displacement current? Varying electric field. Varying electric field. Everybody got? So conduction current is due to the flow of charge and the displacement current is due to the varying electric field. Everybody got or not? Okay. So this is the formula of the one of the formula of the displacement current. I is equal to epsilon naught into d phi E by dt. So basically how we are getting so current we say I is equal to what? dq by dt. When we are talking about the conduction current, okay, varying electric field. Okay, so reason of the why the displacement current produced due to the varying electric field. Okay, varying electric field. This everybody got? Okay. Now I is equal to what? dq by dt. So when we are saying the conduction currents, this we will say I is the rate of flow of charge. Rate of flow of charge. Okay. And this I can say the another way also. I is equal to dq by dt, where dq by dt is the rate of change of charge. Rate of change of charge. So as the capacitor is getting charge, on the capacitor charge is changing. As the charge is changing, then electric field between the plate of the capacitor, what we know, E is equal to sigma by epsilon naught. Okay, sigma I can say what? Q by A into epsilon naught. Now from this we can say what? As the charge is changing, as the capacitor is getting charged, as the charge is changing, electric field is changing. Electric field is changing, then we can say displacement current will be there between the plates of the capacitor. From this you can say Q is equal to A epsilon naught into E. Then dq by dt what you will get? dq by dt you will get A epsilon naught into dE by dt. So that they are written here. I is equal to epsilon naught into d phi E by dt, where phi E is the electric flux. Electric flux formula is what? E dot A. E dot A. Then we will get the formula what? dq by dt will be what? A epsilon naught into dE by dt. So that's why we are saying what is the cause of the displacement current? Varying electric field. Everybody got? So this is the one of the formula of the displacement current. Another formula, I is equal to C into Q is equal to CV between the plates of the capacitor. Q is equal to CV we can write. So what is the dq by dt? I will get C into dV by dt. So that is another formula of the displacement current, C into dV by dt. C into dV by dt. This everybody got? Okay. Up to this okay? Now here in the Ampere law, we were using what? Mu naught B closed line integration of magnetic field. B dot dl is equal to mu naught into I. But now when we are taking the outside, we are taking the disk, then we are getting the magnetic field due to the conduction current. When we are considering the open pot, then we are getting the magnetic field due to the displacement current. That's why Ampere law we are writing as what? Mu naught B dot dl is equal to mu naught IC plus ID. Mu naught IC plus ID. So like outside the plate, we are getting the magnetic field due to the conduction current, and between the plate, we are getting the magnetic field due to the displacement current. So I in the place of I in the Ampere law, we will use what? IC plus ID. Okay. When capacitor is charging, then how much rate charge is flowing in the conducting wire, means conduction current. Same rate charge is changing on the plate of the capacitor. Okay, like suppose I am saying per second Q amount of charge is flowing through the wire. Per second Q amount of charge is flowing through the connecting wire. Okay, so per second Q amount of charge is flowing. Then how much charge capacitor is storing per second? Q. It means I can say rate of flow of charge in the connecting wire is equal to rate of change of charge on the capacitor. That's why we are saying in a capacitor, conduction current and displacement current will be equal. So displacement current between the plate of the capacitor, connecting wire will be the conduction current. Okay, so IC will be equal to ID in the case of the capacitor. So between the plate we will have the ID, outside the plate we will have the IC. Between the plate IC is equal to 0, outside the plate ID is equal to 0. When capacitor get full charge, then no current will flow through the connecting wire. Then IC becomes 0, ID becomes 0. ID becomes 0 doesn't mean that electric field becomes 0. ID becomes 0, it means electric field becomes constant. Why? Capacitor get full charge. So till electric field is varying, then there will be the displacement current. When electric field become constant means capacitor get full charge, then displacement current becomes 0. So capacitor get full charge, that's why you have learned in the current electricity in the capacitor. When capacitor will get full charge, it will behave like an open circuit. Means it will not allow the current. It means conduction current, displacement current both will be 0. Okay. Now this 4 equation, everybody just you have to revise 4 equation already. That is not a new equation. All equation already we have learned in the electrodynamics. So it is a Maxwell electromagnetic equation. 4 equation is there, combining the Gauss law, Gauss law of electrostatics, Gauss law of magnetism, Faraday's law, E dot dl is equal to minus d phi by dt, and Ampere law. Combined 4 is the Maxwell equation. So maybe they are giving the question and they are saying which one is not the Maxwell equation. They are writing something wrong in the anyone. So that 4 you have to remember, it is a Maxwell equation. Everybody got? So source of electromagnetic wave, that already I said what? Accelerated charge particle. Accelerated charge particle, or we can say oscillatory charge particle. When charge particle is oscillated, in the oscillation we have learned oscillation, then it will have the acceleration. Means if they are saying oscillating charge particle we have, so it will produce the EM wave or not? Yes. Why? In the oscillation we will have the acceleration, and accelerated charge particle will produce the EM wave. Second thing, already in the NEET also they asked, in this line they given also, who is the source of the EM wave? Oscillatory charge particle or accelerated charge particle. So what is the EM wave they will produce? Frequency of the E of oscillation of the charge particle. Suppose I am saying any charge particle is oscillating with the frequency f. Any charge particle is oscillating with the frequency f. Then what is the frequency of EM wave it will produce? So EM wave it will produce, that will have the frequency f. So frequency of oscillation of the charge particle will be equal to the frequency of EM wave it will produce. Who is oscillating with high frequency, they can produce the like X-ray, gamma. Who is oscillating with low frequency, they can produce the micro radio. Okay, so one thing you have to remember, frequency of oscillation of the charged particle is equal to the frequency of the EM wave they will produce. Okay, that is given the frequency of electromagnetic wave naturally equal to the frequency of oscillation of charge. Okay. Now in the EM wave, what I said, why we are calling it is an electromagnetic wave, because electric field and magnetic field vector is oscillating. Okay, wave equation already Mohit sir also discussed. Wave equation, we know that y is equal to a sine kx minus omega t. Like this form we are writing, where y in the wave we are saying y is the displacement of the particle, a is the amplitude. Here who is oscillating? Electric field and magnetic field. That's why in the EM wave, in the place of y we are writing E and B. Okay, so E is what? Electric field vector, B is the magnetic field vector, and same like a wave equation. Okay, second thing what you have to remember in that, in the EM wave, electric field and magnetic field, they will be in the same phase, means phase difference between them will be 0. So in the EM wave, electric field and magnetic field vector oscillate in the same phase. They are perpendicular to each other. They are perpendicular to each other. Both electric and magnetic field vector oscillate perpendicular to each other. But what is the phase difference between them? 0. Okay, everybody got? So in EM wave, electric and magnetic field vector oscillate perpendicular to each other, and the phase difference between them will be 0. Okay, so that's why kz minus omega t, kz minus omega t, this part we are writing same in the EM wave. Okay, everybody getting or not? T naught is the peak value of electric field, B naught is the peak value of magnetic field, and the relation between them is what? E naught by B naught is equal to C. This you have to remember, speed of light. E naught by B naught is equal to C. Okay. Next important thing is the direction of propagation. Direction of propagation is what? In which direction wave is energy is propagating. Okay. So direction of propagation of wave is what? It is perpendicular to both E and B. Okay, so how we are giving the DOP? DOP is equal to direction of propagation of wave is what? E cap cross B cap. We cannot reverse. We have to write E cross B because we know that cross product is non-commutative. So we cannot write B cross E. We have to take what? E cross B. So DOP, how we can find? E cross B. And from this, in a vector also we learned A cross B is the vector that is perpendicular to both vector A and vector B. So DOP is perpendicular to both E and B, and E and B are also perpendicular to each other. So means all the three are perpendicular to each other in the EM wave. Okay. Now see, in the optics also we have learned, see, we can find by, in the vacuum, if you want to find permeability and permittivity of the vacuum. If any other medium you want to find the speed of light, then C is equal to 1 upon under root of mu into epsilon. In the place of mu naught, you will use the mu. In the place of epsilon naught, you will use epsilon. Mu is what? Permeability of the medium. Epsilon is what? Permittivity of the medium. Okay. And from that we can get the refractive index. Refractive index of the medium is under root of mu r into epsilon r. This formula you have to remember. What is the refractive index? Under root of mu r into epsilon r, where mu r is the relative permeability, epsilon r is the relative permittivity. Okay. This is the V is equal to 1 upon, in any medium we can find 1 upon under root mu into epsilon. Mu I can write mu naught into mu r. Epsilon we can write epsilon naught into epsilon r. Now in the wave we know that energies who propagate in the wave, disturbance propagate, energy propagate. So in the EM wave, energy is due to electric field and magnetic field. So already in the electrostatics and magnetism we have learned what is the electric field energy density, half epsilon naught into E square. What is the magnetic field energy density? B square upon 2 mu naught. Okay. Same way here, the electromagnetic wave carry the energy and momentum. Electric field energy density, it is the energy density. Suppose they are asking the energy, so they will give some volume. So energy density means energy per unit volume. So due to the electric field, half epsilon naught E square, due to the magnetic field, B square upon 2 mu naught. But if they are asking the total energy in this volume, then they will give the volume. So multiply with the volume, then you will get the energy. Okay, like I cannot say how much total energy we are getting because it is a big volume. So suppose I am saying some volume V and the light is coming from the sun or electromagnetic wave is coming from the sun. So if I know the energy density, I am asking how much energy is in the volume V. So I will say energy density into V. That much energy the volume V will contain. Okay, so if they are asking energy, then it means energy density we have to multiply with volume. Okay. Second thing, in the energy density, what we have to remember, energy density due to electric field and energy density due to magnetic field both are equal. Both are equal. It means they have the equal contribution in the energy of the EM wave. So means energy density due to electric field and energy density due to magnetic field are equal. Okay. Everybody got or not? One confusion is there because somebody mucked up the energy density formula and different energy density. Sometimes we are using half, sometimes we are using factor 1/4. So already I said also, like how we can remember, if I know the electric field, if I know the electric field equation or I know the electric field peak value of electric field and I want to write the total energy density. So total energy density means energy density due to, so U total. Energy density, that is equal to what? Energy density due to electric field plus energy density due to magnetic field. Okay. If I know the electric field and then I want to write the total. So one thing I said, energy density due to electric field and energy density due to magnetic field both will be equal. It means UE is equal to UE is equal to UB. So in the NEET, they ask what is the ratio of the energy density due to electric field and magnetic field. So that ratio is what? 1:1. So U total, what I can say, UE plus UB, UE plus UB. Now both are equal, then I can say U total is the 2UE or I can say 2UB. If I know the electric field, total energy density I will write in the terms of electric field. If I know the magnetic field, total energy density I will write in the terms of magnetic field. So what is the U total? U total I can say what? Half epsilon naught into E naught square, or I can say B naught square upon 2 mu naught. So what I said, if you know the electric field or in the question they are asking what is the electric field and energy density given, then total energy density we will write in the terms of electric field. Half epsilon naught into E naught square. I am not changing the formula what you have mucked up. We have mucked up the energy density half epsilon naught E square. So no need to muck up factor 1/4, some 1/2. What I am saying, if you want to write the total, then half epsilon naught you will write peak square, E naught square. And here half into B naught square. If you are using the peak, it means it is a total energy density, including the both electric and magnetic field. So basic formula same, half epsilon naught E square. If I want total, then in the place of E, I will take E naught. If I want to write in the terms of magnetic field, I will write B naught. But suppose I am asking, what is the energy density due to electric field? So due to electric field means what? I am asking UE. I am asking UE. Then it means it is a half of this. When you will take half of this, so E naught by root 2 is the ERMS. E naught by root 2 is the what? ERMS. So in that case, what I will say, UE is equal to half epsilon naught into ERMS square. So due to the individual they are asking, so in the place of E, we will take ERMS. Total they are asking, so in the place of E or B, we will take the peak value. So when you are writing the peak value, then it means it is a total, including the both electric field and magnetic field. If I am asking individual, then in the place of E, we will use the ERMS. So formula we will not change, half epsilon naught, that will be the same, or B 1/2 mu naught will be the same. Only E naught and B naught, BRMS, ERMS we have to use. If we are writing total, so we will write the peak. If we are writing the due to the each component, then we will write the ERMS and BRMS. Okay. Then another thing is there in the EM wave, because electromagnetic wave means it contains the photon. Photon has the momentum of the photon already we learned in the dual nature in the atom also. Okay, so P is equal to E by C or the H by lambda. So that is written what is the momentum, we can write energy by C. So sometimes they are asking what is the total momentum delivered to the surface when the electromagnetic wave incident on the surface. Okay, so total momentum delivered, force applied or the pressure applied they are asking. So I said the easy way to remember. So here momentum, then force then pressure. Suppose, how to remember, like we learned the quantity first, like momentum, then rate of change of momentum is the force per unit area is the pressure. So here momentum, then force, then pressure, momentum, then force, then pressure. Momentum, first we have learned the quantity momentum, then Newton's second law, rate of change of linear momentum is the force, then we learned the pressure, force upon normal force upon area. So this is the sequence of the quantity, momentum, force and pressure. Other side, if I'm asking, they are asking, what is the total momentum when the electromagnetic wave incident on the surface? What is the total momentum delivered? What is the force applied by the photon on the surface? What is the pressure on the surface? Or they are using the word radiation pressure. So how we will find? Now, left hand side, I said the sequence of quantities what? Momentum, force and pressure. That everybody will keep in the mind. Momentum first we have learned, then force, then pressure. Right hand side, first we learned the quantity energy. Okay, then we learn the power. What is the power? Energy per unit time. Then we learn the intensity, energy per unit area per unit time. So then here momentum, what is the sequence? Same sequence we will write here. First we learn momentum, first we learn energy. So if the surface is perfectly absorbing, then what is the momentum delivered? Energy by C. Energy by C. What is the force applied? Then power by C, and what is the pressure applied? Intensity by C. Here sequence of quantities what? Energy, power, intensity, because first we learn the energy, then we learn the power, then we learn the intensity. If it is a perfectly reflecting, then momentum change will be double. So here we will get 2E by C, here we will get 2 power by C, here we will get 2I by C. So perfectly absorbing, then E by C, power by C, and intensity by C. Perfectly reflecting, then do the multiply with 2 in all above. All the factor multiply with 2. Then we will get the momentum, total momentum delivered 2E by C, total force 2 power by C, and pressure is what? 2I by C. This everybody got? And in this question, it is a simple electric field. They given E is equal to what? 6.3 J cap. They are asking what is the magnetic field at that point. So what I said, E and B, what is the relation? E by B is equal to C. So E they given, B they are asking, C we know, 3 into 10 to the power 8. By this way, directly we will get the B. If I'm asking what is the direction of B, so they given also. What is the direction of the wave? Wave travel in the free space along the X direction. So what is the DOP? I cap. DOP X direction means positive X means I cap. What is the electric field? They given J cap. Electric field they given J cap. So DOP is the I cap. That is what? E cross B. Electric field they given what? J cap. Now what is the magnetic field? So we know that J cross K is equal to I. So magnetic field will be in the K cap. So that is they have written K cap. So 2.1 into 10 to the power minus 8 K cap. Everybody got or not? So magnetic field magnitude we will get by using formula E by B is equal to C, and how we will get the direction? By using DOP is equal to E cross B. Okay. In this problem also, in the wave already we know that By is equal to B naught sine kx plus omega t. If they are asking frequency, we will find the omega. If they are asking the wavelength, we will find the k. From that we can find the wavelength, frequency, whatever they are asking. Okay. Here they are asking the total momentum delivered. If the surface has an area of 20 centimeter square, find the average force exerted on the surface during a 30-minute time span. So they are asking the force. Then for the force, what we will use? Again, sequence momentum, force, then pressure. Here, energy, power. Then for the force, we will take the power. Power is what? Intensity into area. Okay. So now here, if the surface has an area, this, find the average force exerted on the surface during the 30-minute time span. Okay. So for the force, time is not required. So then force we can say directly what? Intensity. This is the what? 18 watt per centimeter square. 18 watt per centimeter square. It is what? Intensity. Watt per centimeter square. Energy upon area into time. They have given intensity. If intensity I will multiply with area, I will get power. What is the area they given? 20 centimeter square. Then what is the power I will get? Power is equal to 18 intensity, and area they given 20 per centimeter square given, and here also area given centimeter square. Then I can get the power in the watt. After getting power, power by C is equal to what? Force applied. Okay. So for the force, time is not required. If they are asking momentum delivered, then this quantity we will multiply with 30 minutes. 30 minutes means 30 into 60. Then I will get the total momentum delivered. If they given the perfectly here light with the non-reflecting surface. Non-reflecting means we will consider the absorbing surface, then we will take the power by C. If they given perfectly reflecting surface, then we will take the 2 power by C. Okay. In this problem, they are saying there is a bulb of power 100 watt. Okay, we have to calculate the electric and magnetic field produced by the radiation coming from 100 watt bulb at a distance of 3 meters. So at a distance of 3 meters, they are asking electric and magnetic field. Okay. So this type of problem, how we can do? We can relate with the intensity. Intensity due to EM wave. I is equal to what? Energy density into C. This also you have to remember. Intensity due to EM wave is what? Energy density into C. Okay. In the wave, we have learned the intensity is equal to what? I is equal to P by 4 pi r square, because if they not mention, always we are considering the point source. For the point source, I is equal to P by 4 pi r square. This and this we will equate U into C. But one thing, they given power here, they given 100 watt, but efficiency they given 2.5%. It means in the place of P, what we will take? 100 into 2.5 by 100. So ultimately what will come? 2.5 watt. So in the place of P, what we have to take? 2.5 watt. Okay. R means 3 we will take. Okay. If you want to find the electric field peak value, then total energy density you will write half epsilon naught into E naught square into C. Then you will get E naught. If they are asking RMS value, E naught by root 2. If you want magnetic field, then this U, what you will put? B naught square upon 2 mu naught. Because what I said, total energy density we can write in the terms of E naught and P naught. Okay. So what they are asking, according to that you will put here. Everybody got or not? Like that way we can do the problem. 4 pi, here epsilon naught will come. So 1 by 4 pi epsilon naught, directly we know 9 into 10 to the power 9. So pi and epsilon naught no need to put separately. They will come with the 1 by 4 pi epsilon naught. Okay. This part is very important. Okay, electromagnetic spectrum. Electromagnetic spectrum, one thing everybody know, the increasing order of the wavelength. What is the increasing of the wavelength? Gamma has the minimum, then X-ray, then ultraviolet, then visible, then infra, then micro, then short radio, long radio, or we can say radio. So first thing everybody has to remember, what is the order of the increasing wavelength? This is the order of increasing wavelength or decreasing frequency. Frequency wavelength, what is the relation? We know that C is equal to F lambda or F is equal to C by lambda. From that we can find the, suppose we know the wavelength, we can find the frequency by using the wave velocity formula. C is equal to F lambda. Okay. So this is the increasing order of the wavelength or decreasing order of the frequency. One thing. Second thing, what is the usage, how we are producing this? Okay. This everybody will just go through the NCERT and once again revise all these points. Okay. So radio wave are produced by the accelerated motion of the charge in conducting wire. In conducting wire, we can produce the radio wave by the accelerated charge particle in the conducting wire. It will produce the what? Radio wave. Okay. First thing, production. Second thing, what is the use of the radio wave? So use you can get in the second line. They are used in the radio and the television communication system. Okay. So one side they will give the uses, one side they will give in the matrix match, what is the wave, then accordingly we have to match. Okay. So here they are used in the radio and television communication, and here also cellular phone are used radio waves to transmit voice communication in the ultra high frequency. So for the voice communication also we are using the radio wave. This everybody got. Okay. So what is the production? What are the uses? This everybody got. Second is the microwave. Microwave This already in the J main they asked this question also. So microwave, that is a short wavelength radio wave, it is called, with frequency in the gigahertz. That is not a problem. How we are producing it? Special vacuum tubes called the klystron, magnetron, and gun diode. These three names you have to remember. Household electronic systems such as TV set, video recorder, and hi-fi system. This everybody got or not? So these points just go to the NCERT once revise again. Okay. Visible rays. When temperature of the body is slightly more, then it will emit the, after the infrared, then it will emit the what? Visible. What is the use of the visible? This everybody know. It run, and what is the range of the wavelength for the visible? Everybody know. Okay. Ultraviolet, when the body is heated at high temperature, then it will emit the ultraviolet radiation. How we are protecting the ultraviolet? What are the uses? So one thing here, uses given also. UV radiation is absorbed by the here. UV lamps are used to kill the germs in the water purifier. This also given in the PACE exam. UV lamps are used to kill the germs in water purifier. Okay, so UV radiation we are using. One thing, due to the short wavelength, it will be the very narrow beam. So we are using in the laser operation also. Here it is also given. UV radiation can be focused into very small narrow beam for high precision. UV radiation can be focused into very narrow beam for high precision applications such as eye surgery. This also given in the PACE exam also. Okay, so here due to the small wavelength, it can be focused into very narrow beam. Okay, so this is the use of the UV radiation. So one thing, for the water purification, for the eye surgery, we are using the UV. Okay. How we are protecting the from the ultraviolet? So ordinary glass absorb the ultraviolet radiation. That's why when they are using the welding arc, so they are putting the glass in the front of the eye to protect their eye from the UV radiation. Okay. X-rays, it is produced in the Coolidge tube. Okay, when the fast moving electron, accelerated electron, they are losing their energy, so they are emitting the X-rays. Okay, X-rays, what are the use? Everybody know, for the scanning purposes, and the X-ray are used for as a diagnostic tool in the medicine and as a treatment for certain form of cancer. Okay. Gamma rays we are getting in the radioactive disintegration. And what is the use of the gamma? They are used in medicine to destroy the cancer cell. We are using the gamma in the medicine. So uses, production is important. First thing, everybody has to read again once this points. And this chart everybody will remember approximately. Some overlapping regions are there, but they will not give the confusing options in the exam. So this everybody has to remember. What is the order of the wavelength? Greater than 0.1 meter, that is a radio. 0.1 to the 1 millimeter, micro. 1 millimeter to 700 nanometer. Otherwise, you can convert into the angstrom and then you can remember. Okay. So 1 millimeter to 700 or 7000 angstrom, we can say infra. 7000 angstrom to the 4000 angstrom, then we can say it is a UV. This range, just remember that. If in the question, suppose they given frequency and they are saying this photon belongs to which radiation, okay, so convert the frequency into the wavelength by using the formula C is equal to F lambda, and after that lambda when you are getting, you can check in which range it is coming. According to that we can say radiation. Everybody got? So this is about the electromagnetic wave. These points again you will revise properly. Okay. One thing in this they have given, an electric dipole is a basic source of electromagnetic wave. This, remember that what I said, electric dipole is the basic source of electromagnetic wave. Electric dipole means positive and negative charges are there, and everything in the universe is vibrating, so nothing is at rest. Okay, even the perfectly solid also, the atoms are vibrating with their frequency. Okay, so when we have the dipole means positive and negative charge are there and they are vibrating, it means they are oscillating charge particle, and oscillating charge particle produces the EM wave. So basic source of the electromagnetic wave we can say electric dipole, that you have to remember. Okay. Now next is the what? Nuclei. So first I am completing the small chapters. Nuclei, nothing but theoretical things, small things are important in the nuclei. Okay. So one thing everybody know, what is the relation between the AMU and the kg, like 1 AMU, 1 U is equal to what? 1.66 into 10 to the power minus 27 kg. In the chemistry also this you have learned. So 1 U is equal to 1.66 into 10 to the power minus 27 kg. Okay. Like chlorine, we are saying the atomic mass number, atomic mass is the 35.5. So mass number is basically, we are saying it is the number of the neutron and proton. But why it is coming in the decimal? So due to the what? In the atmosphere, there are different isotopes are present. When we are finding their average for the all isotope, then we are getting the decimal. Like here, this question has given, for example, chlorine has the two isotope masses. They have given 34.98 and 36.98 unit. Okay, their percentage in the atmosphere is what? 75.4 and 24.6. It means 34.98 is 75%, and the 36.98 isotope, that is the 24.6%. Now, according to the percentage, we are calculating the mass. 75.4 into 34.98 plus 24.6 into 36.98, and total is the 100. So when we divide with 100, we are getting 35.47. So that's why we are getting the mass number or atomic mass of the chlorine is 35.5. Okay, this everybody know. In the chemistry also you have learned. Next thing here, important point, neutron. Free neutron is very unstable. Free neutron is very unstable. So here it has given a free neutron, unlike a free proton, is unstable. Free neutron is unstable. Free proton is very stable. Free neutron unstable. Free proton very stable. That's why they are saying a free neutron, unlike a free proton, is unstable. So free neutron is unstable. Free proton is very stable. It decays into the proton and electron. So like somebody think that how electrons are ejecting from the nucleus, even the nucleus does not contain the electron. In the nucleus we have the proton and neutron. But why the beta particle? Beta particle is what? Basically electron. So why beta particle is emitting? So that is the disintegration of proton. So this reaction everybody has to remember also. Suppose number of proton is more. Number of proton is more from the stability. Number of proton is more, then number of neutron is more. Neutron will disintegrate. Neutron will disintegrate into the proton. How? 1h1 plus minus 1 beta 0 plus anti-neutrino. So this is the disintegration of the neutron. Neutron disintegrate into the proton, and in this one electron or the beta particle form, and with the beta always anti-neutrino. This new bar is the what? Anti-neutrino. So always with the beta, anti-neutrino will eject. Okay, this everybody got. So this reaction everybody has to remember. So in the nucleus electron are not there, but due to the stability, to get the stability, neutron is disintegrating into the proton, and by this relation now beta particle will get ejected. It get ejected, anti-neutrino get ejected. Now in the place of neutron, what we will have? Proton. In the place of neutron. So what will happen when we have mugged up this also? When beta particle is ejected, then the atomic number increase by 1, mass number remains same. Atomic number increase by 1. Now you can see earlier 0, now 1. Atomic number increase by 1 and the mass number remains same. Why? Beta got ejected. Beta got ejected means it came out. Now what is there? In the place of neutron we have proton. Everybody got? So this is the disintegration of the neutron. Similarly, we have the disintegration of proton also. 1h1 is equal to what? 0n1 plus 1 beta 0 plus neutrino. So suppose in the nucleus, heavier nucleus, they have the more protons. So due to the more proton, what will happen? In the heavier nucleus, repulsion will increase because the proton and proton, they repel each other. So due to the more repulsion, what will happen? The nucleus will be unstable. Okay. Because the nuclear force is the short range force, but the nucleus is becoming big, then what will happen? Nuclear force will be the what? Weaker, because the distance will increase. Now, but the proton is unstable. So to get the stability, what will happen? Proton will disintegrate into the neutron. By this relation, proton will convert into the neutron and the positron will form. Positron will get ejected. Now in the place of proton, what we have now? Neutron. Everybody got? So positron is emitted due to the disintegration of neutron, and beta ejected due to the disintegration of neutron and neutron will convert into the proton. Okay, so this relation you have to remember. One thing we asked in the exam also, that also you have to remember, beta emission or the beta emission is the continuous spectrum, because energy whatever the in the disintegration process, that is mainly first it is divided in the all product in the form of kinetic energy, and then due to the atmosphere it will convert into the heat and sound whatever. Okay, so majorly first all the energy, whatever the energy released in the release, that will distribute in the anti-neutrino and beta particle, and randomly it will disintegrate, means we cannot say the beta will get this amount and the anti-neutrino will get this amount. So they can have any variation. Means suppose the X amount of energy release, so beta can get X, anti-neutrino will be negligible, or anti-neutrino can get X, beta will be negligible. So there is a random distribution of the energy between the beta and the anti-neutrino. That's why all possible energy of the beta we can get. That's why we are saying the beta emission is the continuous spectrum. So remember that in the radioactive disintegration, beta is the continuous spectrum. Okay. Everybody got? So what I said, free neutron is unstable, very unstable. Free proton is very stable. Okay, and then it decayed into the proton and electron. That already I said. Mean life of about 1000 seconds. Neutron mean life. Free neutron mean life is about 1000 seconds. Okay, this everybody got? So free, what I said, free neutron is very unstable. Mean life is 1000 seconds. Free neutron is very unstable. Mean life is 1000 seconds. Free proton is very stable. Free proton is very stable. So free over. Inside the nucleus, both are stable. Inside the nucleus, both are stable. Both neutron and proton are stable inside the nucleus. Okay. But inside the nucleus, both can disintegrate also according to the need of the stability. Okay. So inside the nucleus, both are stable, but both can disintegrate also. So proton will only disintegrate inside the nucleus. Proton will only disintegrate inside the nucleus. Okay. Free proton will never disintegrate. One thing in the JMN also they ask this question, and I will show that line has given in the NCERT also. So free proton never disintegrate. Proton will only disintegrate inside the nucleus. Free neutron is very unstable. Inside the nucleus it is stable, but inside the nucleus it can disintegrate also. So what I said, inside nucleus both are stable, but both can disintegrate according to the need. Okay, this line has given here. It is however stable inside the nucleus. So neutron is stable inside the nucleus. Okay. Then radius formula for the nucleus is what? R is equal to R naught into A to the power 1 by 3. Means radius of the nucleus is directly proportional to A to the power 1 by 3. So R is directly proportional to A to the power 1 by 3. And what is the formula? R is equal to R naught into A to the power 1 by 3, where R naught is the 1.2 Fermi meter or 10 to the power minus 15 meter. Okay, by this formula we can find the radius of the nucleus, where A is the mass number. Like I am saying 13Al27. What is the radius? So A I will put 27. 27 cube root is what? 3. From that we can find the radius. Okay. Everybody got? Now by this, if I am saying what is the volume of the nucleus, so volume is the 4/3. We are considering like a point or the sphere. So what is the volume of the sphere? Volume of the nucleus 4/3 pi r cube. When you will take the r cube, then here you will get the A, because 1 by 3 power 3. What you will get? A. So means volume is directly proportional to A. So volume of nucleus is directly proportional to mass number. Okay. Mass of the nucleus is directly proportional to mass number. So mass of the nucleus is directly proportional to the mass number. So what is the density? Density is what? Mass by volume. Mass is directly proportional to mass number. Volume is directly proportional to mass number. Then density will be what? Independent of the mass number, because density is the mass by volume. A and A will get cancelled out. So density of the nucleus is independent of the mass number, whether helium, whether uranium. Approximately we can say the density for all nucleus are same, and that is the order of 10 to the power 17. Directly remember this value. It is approximately what? 2.3 into 10 to the power 17 kg per meter cube. 2.3 into 10 to the power 17 kg per meter cube. It is the density of the nucleus, and it is constant for all the nucleus. It doesn't depend upon the mass number. Okay. Here they have calculated that value also, like nuclear density is a mass by volume. So mass number 55.85, then they have converted into the kg by multiplying 1.66 into 10 to the power minus 27. Then mass you got volume 4/3 pi r cube. By taking the r cube, then A you will get that A is coming 56. Okay. By putting the values, we are getting 2.29 into 10 to the power 17 kg per meter cube. Unit also you have to remember. Maybe suppose in the exam they ask in the unit of the kg per centimeter cube, gram per centimeter cube. According to that, order will change. So it is the order of 10 to the power 17 in the unit of kg per meter cube. Okay. Then energy and mass are the equivalent. So basically what is happening in the nuclear reaction, the energy of all nuclear reaction, what is the reason of the energy release? That is the mass loss. So mass is equivalent to the energy, and Einstein has given the relation for that. E is equal to what? mc square. This everybody know. E is equal to, I said what is the actual equation of the Einstein, but that is not required in this chapter. E is equal to mc square. So suppose my rest mass is m, my mass is m. So due to my mass, how much energy I have? E is equal to mc square. That is called the rest mass energy of the body. Okay. So E is equal to mc square, where m is the mass of the particle or mass of the body. Suppose I am saying mass m get destroyed. Mass m get destroyed. How much energy will release? So how much energy will release? E is equal to mc square. So we will multiply how much mass loss is there, that we will multiply with c square. You will get the energy released in the mass loss. Okay. So this has, they calculate the energy equivalent to 1 gram of the substance. 1 gram of the substance means mass is the 1 gram, that is a 10 to the power minus 3 kg, into c square is what? 9 into 10 to the power 16. When you will multiply, then you will get the how much energy? 9 into 10 to the power 13 joules. So 1 gram mass is equivalent to how much energy? 9 into 10 to the power 13 joule. So suppose I said 1 gram mass destroy, completely destroy, how much energy release? Then I can say 9 into 10 to the power 13 joule. Okay. Now what is the binding energy? So binding energy means the energy by which nucleons are, like when we are making the nucleus. Making the nucleus means neutron and proton will be inside the nucleus. So when the nucleus form, in the formation of the nucleus, some mass get destroyed. Some mass get destroyed. So where that mass will go? Mass will convert into the energy by the relation E is equal to mc square. So in the formation of nucleus, some energy releases. Why energy releases? Because of the mass loss. So energy releases in the formation of the nucleus. That energy is called binding energy of nucleus. Another way also we can define the binding energy, that is the energy required to isolate all the nucleons. Like suppose I am saying in nucleus we have the 10 neutron, 10 proton are there. Okay, how much energy required to isolate all the 10 neutron and 10 protons? That is equal to what? Binding energy. So binding energy is what? Energy released in the formation of the nucleus, or another way we can say energy required to isolate all the nucleons. Okay, that has given the definition here also. Okay, the energy EB is called the binding energy of the nucleus. If we separate a nucleus into its nucleon, we would have the supply the total energy equal to EB to those particles. So if you want to isolate, you have to give the same amount of energy. Got it? How we can calculate? So we will calculate the mass loss first. Masses if they are giving. So we will find what? Suppose I am saying 10 proton and 10 neutrons are there. So what should be the actual mass of the proton and neutron? So 10 into mass of proton plus 10 into mass of neutron. Okay, this is the total mass of the neutron and proton. Then minus actual mass of the nucleus. So suppose I am saying I am getting X is the total mass of nucleon. Y is the actual mass of nucleus. So how much mass loss? X minus Y. That we will multiply with the C square. You will get the binding energy. But in whole chapter, nuclei chapter, we will deal the energy in EV, MEV. So that's why you have to remember, if the mass loss you know in the kg, gram, okay, then we will multiply C square to get the energy. C square is what? 9 into 10 to the power 16. But if they have, we know that mass loss in AMU or U, okay, in the AMU, just remember that 1 AMU is equal to how much energy? 931.5 MeV. So when you know the mass loss in the AMU, then we will multiply to get the energy. We will multiply with 931.5 MeV. If you know the mass loss in joule or kg, then we will multiply with c square, then answer we will get in joule. Okay, so when I know the mass in kg or gram, I will multiply with c square, then I will get the energy in joule. If I know the mass in AMU, mass loss in AMU, then I will multiply with 931.5, and then answer of the energy I will get in MeV. Okay. So then what is the binding energy formula? First we will calculate the delta M, mass loss. Mass loss is what? ZMP. ZMP means atomic number. Atomic number means number of proton into mass of proton. A minus Z is the number of neutron into mass of neutron. So this is the total mass of neutron and proton minus actual mass of the nucleus. You will get mass loss. After getting the mass loss, multiply with 931.5, you will get the binding energy in MeV. Okay, like that they have calculated here. Then now this is the binding energy curve. This is so binding energy curve means here what is happening. On increasing the mass number in the beginning, we can say binding energy per nucleon. And one more thing, we are not defining the stability on the basis of binding energy. We are defining the stability on the basis of the binding energy per nucleons. Means suppose the nucleus is very big, then what will happen? Its binding energy will be more. But per nucleon, how much energy required to isolate them? We will decide the stability from that factor. We will not define the stability from binding energy. So binding energy per nucleon. Whose binding energy per nucleon means each nucleon required more energy to separate, that is nucleus will be more stable. So for the stability we are checking binding energy per nucleon. Okay, so this is a binding energy per nucleon curve and the mass number. In the beginning, when we increase the mass number, binding energy per nucleon increases. For mass number 56, binding energy per nucleon is maximum. That is what? For 56, it is a 8.75 MeV. That is the iron mass number 56 is for Fe. So it has a maximum binding energy per nucleon, that is a 8.75. For 238, it is a lesser, that is a 7.6 MeV. Okay, one thing. Second thing, if you see the binding energy curve, we are getting the peaks in the curve. Suddenly this He is in the peak, then we are getting fall, then peak, then fall. What is this peak? Why we are getting this type of peak and fall in the binding energy curve? So when the number of proton and neutron are even, in the nucleus, so that nucleus will be relatively more stable. Okay, that's why suddenly stability rise. When both is the odd, suddenly stability will fall. Again, suppose it become even, then stability will rise. So when we have the even number of neutron and proton, then due to the spin, we can say we have the same type of spin structure, spin in the nucleus also. So when both are the even, it means the spin will also balance, then that nucleus will be more stable. When both are odd, then that nucleus will be comparatively less stable. So you can see also in the peak, we are getting helium, carbon, oxygen. Helium 2He4, 2 proton, 2 neutron. Carbon 6C12, 6 protons, 6 neutron. Even, both are even. Oxygen 8O16, 8 proton, 8 neutron. So these nucleus are relatively more stable. That's why suddenly stability rise. They are on the peak. When we are taking the fall, like nitrogen, 7 nitrogen 14, so 7 7, both are odd. That's why relatively stability fall. Then fluorine 9F 18, so means 9 9 odd. So stability will fall. Everybody got? So why we are getting the rise and fall in the this binding energy curve? Because of the even number of neutron and proton. Here they have given in the range of the mass number is 30 to 170. Binding energy per nucleon is almost constant. If you see the 30 to 170, there is no more changes are there. Almost it is constant. Okay. So one thing, one question like suppose I am saying assertion is in the range of mass number 30 to 170, binding energy per nucleon is almost constant. Okay. What is the reason? One reason is what? Suppose any nucleon that is surrounded by some nucleon. Okay. After that, when we are increasing the mass number, so all the other nucleon, their force on this nucleon will be negligible because nuclear force is the short range force. So then what will happen? The force on this nucleon, suppose it is any proton, it is surrounded by some proton and neutron. Another layer we are getting. Now as we are increasing the mass number, their force on this proton will be what? Negligible. That's why there is no effect on the binding energy per nucleon in the range of 30 to 170. So What is the reason? Suppose assertion I am giving the binding energy in the range of the 30 to 170, binding energy per nucleon is almost constant. So what is the reason? Because nuclear force is the short range force. In this line also they have given. The constancy of the binding energy in the range 30 to 170 is a consequence of the fact that nuclear force is the short range. Nuclear force is the short range. In the JEE Main 2023, exactly same question they asked. In the mass number range 30 to 170, binding energy per nucleon is almost constant. Reason they given what? Nuclear force is the short range force. So both are, reason is the correct explanation or not? Yes. So remember this line, what I said, binding energy per nucleon in the 30 to 170 is almost constant. Why? Because nuclear force is the short range force. Okay. So lighter nuclei means you can see also in the beginning when the mass number increasing, binding energy per nucleon increasing means stability increasing. So lighter nuclei shows the fusion reaction and the heavier nuclei shows the fission, because they will split into the lighter nuclei. Lighter nuclei they will fuse and they will make the bigger nuclei. Okay. So like hydrogen, it will fuse into it will form the helium. Uranium is split into the two lighter nuclei, then the stability will increase. Okay, so lighter nuclei shows the fusion, and the heavier nuclei shows the fission. Okay, everybody got nuclear force. What is the nuclear force? Nuclear force means it is a very short range force. Due to that, so it doesn't depends upon the charge and mass. So neutron, proton, proton, neutron, nuclear force is same. Okay. Second thing, it is attractive in nature and it is the strongest force in the range. Its range is very small. It acts in the order of the Fermi meter, but in that range it is the strongest force. So nuclear force is the strongest force in the range, but when the distance will be more, then what will happen? This force will be negligible. But in the range of the Fermi meter, this will be the strongest force. That's why in the nucleon, even the proton has the positive charge. They have the electrostatic repulsion, but inside the nucleus they reside inside they are inside the nucleus because of the nuclear force, and nuclear force is the attractive. Okay, this everybody got. So what I said, for the nuclear force, if I'm asking the order, so it is approximately same. This line also given here also. The nuclear force is much stronger than the Coulomb force acting between the charges or the gravitational force between the masses. The nuclear force binding has to dominate over the Coulomb repulsive force. That's why proton inside the nucleus, proton are staying. Okay, the nuclear force between the two nucleon falls rapidly to the zero as the distance is more than the few Fermi meter. What I said, up to the Fermi meter is the strongest, but when the distance is more, this force will be negligible. Okay. This leads to the saturation of force in the medium of large size nucleus. So when the nuclear size is large, then the what is happening? Nuclear force is not effective. Why? It is the nuclear size become big. That's why heavier nucleus are the unstable. Okay. Second thing, this just point that remember that the force is attractive. From this graph you can see up to this force is attractive, less than that force will be repulsive. This graph you have seen in the mechanical properties of solid, in the chemical bonding. Here also it has given. So up to this force is attractive, less than that force will be repulsive. So when this means that the force is attractive for distance larger than 0.8 Fermi meter. It should be order of Fermi meter, but it should be the more than 0.8 Fermi meter, then the force will be attractive. If it is a less than that, 0.8 Fermi meter, less than that distance between the nucleon, then the nuclear force will be repulsive. So more than 0.8 Fermi meter, nuclear force will be attractive, and up to the Fermi meter order it will be otherwise large distance, nuclear force will be negligible. Okay, but less than 0.8 Fermi meter, if the distance is there between the nucleon, then nuclear force will be repulsive. Okay, so nuclear force, if our order of nuclear force we are asking, so it will be equal in proton, neutron, and neutron, because it doesn't depend upon the mass and the charge. Here also given also the nuclear force between neutron, proton, and proton is approximately the same. Suppose they given the statement approximately the same, so don't get confused. Sir said the equal. So approximately the same in the NCERT they has given approximately the same, or if approximately option is not there, they are saying it is the same, then we can say nuclear force between the proton, neutron, and neutron are equal. Okay, but if they are asking the net force, then net force how we can find? Net force means Proton, neutron, no repulsion. Neutron, neutron, no repulsion, means they will have only nuclear forces. But proton and proton repulsion is there. So nuclear force is attractive, electrostatic is repulsive. So net force will decrease. So if they are asking the order of net force, so it will be minimum in proton and proton. So that is the order of the net force. Proton, proton is less than proton, neutron and neutron, neutron. Okay, why? Because proton, neutron and neutron, neutron only attractive nuclear force. But in proton and proton, nuclear force and the electrostatic repulsion, so net force will decrease. Okay. Now radioactivity, law of radioactivity is not there in the syllabus now. Alpha decay, gamma decay, beta decay, just now I explained also. Beta, why beta decay is there? Because the neutron converting into the proton. When heavier nucleus is there, then suppose sometimes they are emitting the alpha particle. Alpha particle is the helium nucleus, that is a 2He4. So mass alpha particle will get ejected, so mass number will get reduced by 2. Mass number will atomic number will get reduced by 2, and the mass number will reduce by 4. Okay, so that is the parent nuclei who is ejecting the alpha, and daughter nuclei, the product, then mass number will be decreased by 4, and the atomic number will decrease by 2. Okay. Gamma decay means what? For the gamma decay, one graph also given. This radioactivity, no need to read, no need to read, no need to read, no need to read, no need to read. Alpha decay already I said, mass number will decrease by 4, atomic number will decrease by 2, and that also I said, whatever the energy released in the reaction, that energy first it will go in the form of kinetic energy in all the product, and then due to the atmosphere, earth atmosphere and all energy, it will convert into the heat or the sound. Okay. So here, like we have given the following atomic masses given, then show that the 92 uranium-238 cannot spontaneously emit a proton. So here this reaction, just remember that 92 uranium-238, if it is ejecting the proton, then reaction will be what? 92 uranium-238 is the 91-237 plus 1H1. Okay. All masses given, if you calculate the mass of reactant and mass of product, then what you will find? Mass of reactant minus mass of product will come negative. Mass of reactant minus mass of product is negative. It means here mass loss is not there. I said, why the energy release in any nuclear reaction? Because of the mass loss. Mass loss means what? Product mass will be lesser than the reactant mass. Means some mass will convert into the energy by the relation E is equal to mc square. But if the mass of reactant is lesser, mass of product is more, that the reaction will be spontaneous? No. So here, this example, remember that 92 uranium is ejecting the proton, suppose they said, and they given the masses 92 uranium-238 ejecting the proton, and masses they given, they are asking this reaction is spontaneous or not. So first find the mass defect. Mass defect, how we are calculating? Mass of reactant minus mass of product. If it is coming positive, means reactant mass is more than the product, it means some mass loss is there and energy will release. So reaction is energetically energy, on the basis of energy, reaction is possible. But suppose I am saying mass of reactant is less, mass of product is more. Mass of product is more. It means mass is increasing. Then this reaction is not spontaneous. We have to give some energy to start this reaction. Okay. So in this problem, 92 uranium-238, it cannot spontaneously emit a proton. Why? Because if I write the reaction, so 92 uranium-238 is the 91 Pa237 plus 1H1. Now when you calculate the mass loss, mass of reactant minus mass of product, it will come negative. If it is coming negative, means mass loss is not there. It means energy will not release. So this reaction will not be spontaneous. Everybody got or not? So spontaneous, non-spontaneous reaction they are asking. So first we have to check the mass of reactant and mass of product. If the reactant mass is more, product mass less, means mass loss is there, means energy will release, this reaction is spontaneous. Second thing, if they given binding energies, of reactant and product, so reverse we will do. Binding energy of the product minus binding energy of reactant. For the mass, reactant minus product, mass loss into 931.5, you will get the energy. For the masses given, But when they given the binding energies, then reverse we will do. Binding energy of the product minus binding energy of the reactant. Binding energy of product minus binding energy of reactant. If it is a positive, energy release, spontaneous reaction. If it is a negative, energy absorb, non-spontaneous reaction. So binding energy is given, so product minus reactant, mass is given, so reactant minus product into 931.5. When binding energy is given, no need to multiply with the 931.5. Directly binding energy of product minus binding energy of reactant is the energy release of absorb. Getting or not? And binding energy of proton, neutron, elementary particle is 0. So if the binding energy we are using and proton and neutron are in the reaction, their binding energy we will take 0. But in mass, we will consider their masses also. Okay. Beta decay, already I said beta, how it is ejecting by the what? When the neutron convert into the proton, and with the beta always anti-neutrino will emit. With positron always neutrino will emit. Okay. Neutron, this conversion they given, that already I said. Gamma decay, just remember that gamma is the photon. Okay. Why the gamma decay? So suppose I have the radioactive nucleus. Radioactive nucleus means unstable nucleus. So unstable nucleus means its energy is high. So it is in the higher energy state. Suppose it emit the positron, it emit the alpha, or it emit the beta. So then its stability will increase. Why? Why they are ejecting? To gain the stability. So suppose we have the radioactive nucleus. Radioactive nucleus means unstable. So its energy is high. Now they are ejecting the alpha, beta, or the positron. So they will gain the stability. So their energy will decrease. So inside the nucleus also, by this paragraph they have explained, inside the nucleus also we have the energy level like an atom. In the atom we have the energy level, the difference is in the EV. But inside the nucleus we have the energy level, the difference is the MeV. Okay, million electron volt. So here it has given, suppose any radioactive nucleus we have, unstable nucleus we have, it emit the beta minus, finally it is converting into this 28 nickel 60. Okay, then here they have shown the two transition, E1 and E2, E gamma. So if they have given, so suppose I am saying what is the energy of the gamma emitted, so energy of the gamma photon will be 1.17 and 1.13. so directly they have shown from here to here, then I can say what is the energy of the gamma emitted, 1.17 plus 1.33. But according to this figure, when 627 cobalt 60, it emit the beta, it is unstable, it ejected beta, its stability increase. So it will come from higher energy level to the lower energy level. Then it convert into the 28 nickel 60. Whatever the difference of energy between the energy level, that is the energy of the gamma photon. If they are saying in this transition 2 photon emitted, so 1 photon will have energy 1.17 and 1.33. If only 1 photon emitted, directly this plus this. Understood or not? Like this way we can say inside the nucleus also we have the energy level, but that energy level is in the MeV. Okay. Nuclear energy, what is the reason of the nuclear energy? Nuclear energy reason is the what? Mass loss. All nuclear energy, wherever the energy release, the energy reason is what? Mass loss. Okay. Even binding energy also, the what is the reason? Mass loss. Okay. Then fission means splitting of the heavier nucleus into the smaller nuclei. One fission of the uranium they have shown. In that 3 neutron eject per and on an average, if they are asking per fission how much average number of neutron ejected, so remember that is a 2.5. In some line it has given also. Okay. So in some reaction 3, some reaction 2 is ejecting. So on an average, what is the number of neutron ejected in the nuclear fission reaction? That is a 2.5. Okay. So here the disintegration energy in the fission emits first appear as the kinetic energy of the fragment and the neutron. What I said, whatever the energy released, it will go in the form of kinetic energy. Eventually it is transferred to the surrounding matter appearing as a heat. After that it is transferred to the surrounding in the form of heat. Okay. Now here also average 2.5 neutron are released per fission of the uranium nucleus. So what is the average number? 2.5. Got it or not? Now nuclear fission and nuclear fusion. So controlled chain reaction then we can use the energy of that energy. So nuclear reactor is based on the controlled chain reaction, okay, and nuclear bomb is based on the uncontrolled chain reaction, because continuously energy is releasing and continuously fission is going on. So then uncontrolled chain reaction, nuclear bomb, and controlled chain reaction, the fission is going in the controlled manner, then that energy we can use. So that is our nuclear reactor. So to carry out the fission in the controlled manner, we have to absorb the neutron. So we need neutron absorber and neutron moderator. What is a neutron moderator? They slow down the fast moving neutron, otherwise neutron can penetrate your nuclear reactor without doing the fission. So we need to slow down the neutron. So that is called the neutron moderator. Neutron moderator, what we are using as a neutron moderator, water, heavy water, or the graphite rod. Here they have given also somewhere. So here isotope uranium, this, then neutron moderator, what I said, it is used to slow down the fast moving neutron. Neutron absorber means they are absorbing the neutron, because if the neutron number is continuously increasing, so fission will continuously increase. So we need to absorb some neutrons. So for that purpose, we are using the neutron absorber. So boron and cadmium rod we are using as a neutron absorber, and the neutron moderator means to slow down the neutron. Moderator is used to slow down the neutron. What I am saying, heavy water, graphite rod we are using as a neutron moderator. Best moderator is the heavy water, okay, that you have to remember. Neutron absorber is what? It is absorbing the neutron, so that number of neutron is not continuously increasing, okay. Then nuclear fusion. Nuclear fusion means lighter nuclei, they are combining, they are forming the heavier nuclei. Like suppose I am saying not heavier, relatively heavier means hydrogen fuse, and they are forming the helium. So in the nuclear fusion, one thing we have to remember, what when the two nucleus is going to fuse, means they are going to meet. So nucleus has the positive charge, so positive charge will repel each other. So to overcome the repulsion force, we need some high kinetic energy. So they will go with a very high kinetic energy and they will fuse. So that's why fusion reaction take place at high temperature. Why? To cross the Coulomb barrier. That point also given. When fusion is achieved by raising the temperature of the system, that particle have enough kinetic energy to overcome the Coulomb repulsive behavior. It is called thermonuclear fusion. So fusion reaction take place at high temperature. That's why it is called the thermonuclear fusion reaction. Okay. Second thing, what here 4 hydrogen atom combine to form an 2 He4 atom with the release of 26.7 MeV of energy. 4 hydrogen, how much? 26.7. So per hydrogen atom, how much energy released? 26.7 by 4, approximately 6 point something will come. But in the fission, per nucleon, around 1 MeV is releasing. So where we are getting the more energy per nucleon? In the fusion. But fusion takes place at high temperature to overcome the repulsion force between them. If the calculation of the temperature, they are asking how much temperature required to overcome the repulsive force. So we will use this relation. Thermal kinetic energy 3 by 2 kBT, Boltzmann constant. It has to be equal to the like potential energy at the minimum distance 1 by 4 pi epsilon naught Q1 Q2 by R. Okay, by this kinetic energy we will equate at the potential energy at the closer distance. By that you can find the temperature required. Okay. So this is almost over. Okay, so questions you will solve. One more thing in the old NCERT, this statement has given. Every particle there exists the antiparticle. Every particle there exists the antiparticle. Particle antiparticle means what? Like electron and positron. They are the antiparticle of each other. Okay. Antiparticle means what? When they will combine, they will destroy each other. So proton and electron and positron, they have the equal mass but opposite charge. So then these particles are called antiparticle. Equal mass, opposite charge, they called antiparticle. So like electron, what is antiparticle? Positron. Proton, what is antiparticle? Antiproton. So every particle there exists an anti-particle also. This statement given in the old NCERT, but in the new NCERT, this statement has removed. Okay. This also the fusion, I said that the fusion, the light nuclei must have sufficient initial energy to overcome the Coulomb potential barrier. Coulomb barrier, that is what? Repulsion force between them. To overcome the repulsion force, we need high kinetic energy. Okay. This question you will solve, like most of the question are same, like mass defect we have to calculate and we have to find the energy. One question is there in that you will solve, and you have any doubt then you can ask also. Here, this question 13.19, 13.19, 13.18, it is based on the nuclear reactant and nuclear fusion. How long can electric lamp of 100 watt be kept glowing by fusion of 2 kg of deuterium? Okay, so this you will do what, like what, 2 deuteron, they form 2He3. So 2 deuteron, how much energy released? 3.27. So 2 deuteron 3.27, so 1 deuteron 3.27 by 2. So per deuteron how much energy you got? 3.27 by 2. How much total deuteron we have? 2 kg. So 2 kg, so 2 into 10 to the power 3 by 2, then you will get the number of mole. In 1 mole, how many nucleus will be there? Avogadro number. So you will get the total number of deuteron in the 2 kg of deuteron. Okay. After getting the total number of nucleus, per nucleus we are getting 3.27 by 2 MeV. So then that much of deuteron, how much energy will give? So per deuteron into total number of deuteron, we will get the total energy. Total energy after getting, then they are saying what is the power we need? Power we need 100 watt. So they are saying how much time the total deuteron will take to disintegrate. So suppose I have the total number of the x deuteron into energy due to 1 deuteron, it is the total energy. That is equal to power into time. From that you can calculate the time. So this question everybody will solve. So 3.18, 13.18 and 13.19 you will solve. Okay. Now small chapters, photoelectric effect. First we will complete this fast. Just 2-minute break, I will drink water. Okay. Now dual nature, this chapters are small, we can complete fast. Now everybody know that why I am taking these two chapters, why I have discussed these two chapters first. Okay. Okay, then now electron emission in the photoelectric effect. First is the electron emission. How we can eject the electron. There is a different ways are there. 4 ways are given here. Like thermionic emission, field emission, photoelectric emission. Thermionic emission means when the electron is ejecting due to the temperature. That is called the thermionic emission. When electron is ejected due to the electric field, that is called the field ejection. It happens in the semiconductor also. Electron is ejecting due to the electric field. Okay, so that is called the field ejection, when electron ejected due to the electric field. And photoelectric emission means when electron is ejected due to the suitable light or suitable wave, or then it is called the photoelectric emission. When light of suitable frequency illuminate a metal surface, electron are emitted from the metal surface. Okay, so these are the 3 ejection. Then photoelectric effect, basic things, basic definitions. We have to know what here. Now this is the setup of the experiment. Means here this is the emitter or cathode. When the light is suitable frequency fall on the metal plate, then what will happen? Due to the absorption of photon, electron will get ejected. Those electrons are called photoelectron. Here we are taking the collector, and by this we can this figure is little bit complicated for you, but here why they have made the figure like this. By this we can change the applied potential. Okay, so sometimes we can give by reversing the polarity, we can give the negative potential to the anode. Then by that we can decrease the kinetic energy. By connecting with the positive terminal, we can increase the potential here, so it will get the kinetic, electron will gain the kinetic energy. Okay, so in the photoelectric effect experiment, when we are talking about the intensity in the photoelectric effect, so intensity basic definition is the energy per unit area per unit time. So E upon A into T is the intensity. But in the photoelectric effect, we are dealing with the particle nature, because this wave nature cannot verify, we cannot explain this phenomena by the wave nature. So that's why we are saying the dual nature of the radiation, means the radiation has the both particle nature and the wave nature. Okay, so this experiment we can only explain on the basis of the particle nature, and there are so many reasons are there that I will cover in the next. So what I'm saying here, intensity basically we are saying energy per unit area per unit time. But here we are dealing with a particle like a photon. Energy is like a energy transfer in the form of the particle. So when we are saying here intensity, and I said the frequency of photon is constant, then frequency photon constant means energy of the photon is constant. Energy constant, then intensity will be directly proportional to the number of photon. Okay, so for the given frequency in the photoelectric effect, we will say for the given frequency, intensity is directly proportional to the number. Okay, so here effect of intensity of light on photocurrent. So suppose electrons are ejecting due to the photon. Suppose I am saying 20 photon incident, approximately 10 electron ejected. Now 40 photon incident, 40 will, so number of photon incident increase means intensity increase. Intensity increase, number of electron will eject more. Number of electron eject more, then current will increase. So which ratio we are increasing the number of photon incident? Same ratio, number of electron ejected will increase. So that's why here it is saying the photocurrent is directly proportional to the number of photoelectron emitted per second. The photocurrent is directly proportional to the number of photoelectron emitted per second. This implies that the number of photoelectron emitted per second is directly proportional to the intensity. Number of photoelectron, how many photoelectron will eject, that will depends upon the number of photon incident. Number of photon incident is what? Directly proportional to the intensity when we are saying the frequency of photon is constant. Okay, so here we are saying what? The number of photoelectron emitted per second is directly proportional to the intensity of incident radiation. So means photocurrent is directly proportional to the intensity if the frequency of photon is constant, and that frequency is more than the particular frequency, that is called threshold frequency. So when frequency of photon is more than threshold frequency, then photocurrent is directly proportional to intensity. So what is the graph we will get? Intensity of light and photocurrent will be the straight line. Okay, why? Intensity of light increasing means number of photon increasing, then current is also increasing. Okay, Then effect of potential on the photoelectric current. Potential, what I said, one thing, potential is not ejecting the photoelectron. Who is ejecting the photoelectron here? Photon. Okay, so after ejection there is a role of the potential. So one thing, potential will not cause the ejection of the photoelectron here. Okay, so how we can how the photocurrent will get affected by the potential? So suppose we are giving the collector positive potential, so they will increase the kinetic energy of the photoelectron, so the current will increase. Okay, but when we are giving the negative potential to the collector, then they will oppose the motion of the electron, so photocurrent will decrease. Okay, so like that way it will affect the photocurrent. Okay, if I am saying here, they are saying like it is a found that the photocurrent increases with increase in positive potential. So when you are increasing the positive potential, then it will increase the kinetic energy of the photoelectron, then current will increase. Okay, at some stage for a certain positive potential of the plate A, all the emitted electron are collected by the plate A and the photoelectric current become maximum or saturate. I said what is the saturation current? Whatever the photoelectron ejected, all start reaching to the collector. Means then after that, if even you are increasing the potential, then the current will not increase. Suppose I am saying per second 20 photoelectron ejected and 20 are reaching to the collector. So then current, after that, if I am increasing the anode potential, then there is no meaning, because what I said, potential is not ejecting photoelectron, only potential is increasing or changing the kinetic energy. So when all are ejected, they start reaching to the collector, then current become constant or the maximum or the saturation. Okay, if after that you want to increase the current, you have to increase the number of electron. To increase the number of electron, earlier I said what, we have to increase the number of photon, or we have to increase the intensity. Okay, but for the given intensity, for the given number, whatever the photoelectron ejected, when they start reaching to the collector, then current will become constant, or that current will be the maximum. That current is called saturation current. Okay, so here the saturation current on increasing the potential, saturation current does not increase when we are not changing the intensity. Okay, so the maximum value of the photoelectric current is called saturation current. Saturation current corresponds to the case when all the photoelectron emitted, the emitter plate C reaches the collector plate A. All the electron ejected, they are reaching to the collector, current become constant. Okay, so this is the graph. It is showing the saturation current. Like when we are giving negative potential to the collector, then what will happen? It will oppose the motion of the electron. So electron velocity will decrease. And suppose I am decreasing all electron kinetic energy, decreasing. I am increasing the negative potential of the collector. At some negative potential, what will happen? All electron will stop there. They cannot reach to the collector. So then that negative potential of the collector, for which photocurrent becomes zero, that is called the stopping potential. Stopping potential means all electron, no any electron can reach to the collector. The current becomes zero. So that negative potential of collector is called stopping potential. Stopping potential will be always negative potential. That also you have to remember for a particular frequency. Now this shows what stopping potential means. Current is zero. This is the graph between photocurrent and the potential. For negative potential, photocurrent is zero. After that, we are increasing the potential of the collector. Then what is happening? Current is increasing. But after some certain potential, when we increase the potential now, there is no meaning, because suppose 20 electrons are ejecting, now 20 start reaching to the collector. Now current become constant. After that, even I am increasing the anode potential, current will not increase. So we got the saturation current. That's why we are getting the graph like this. Okay, if I want to further increase, I want to increase the current by same photon, then I have to increase the number of the photon. Number of photon increase, number of electron ejected increase. Then saturation, suppose now 40 electrons are ejecting, then saturation means 40 electron will reach to the collector. Then what will happen? Photocurrent will increase. So these are means what? This intensity here, intensity is more than this. Means here number of photon is more than this. Why? They started with the same point. Means energy of the photon is same. Means frequency same or energy of photon same. Energy of photon same, then how I can increase the intensity? By increasing the number. So I can say here number of photon is more than the number of photon here. It means intensity of this is more than intensity of this. Suppose this is intensity I2, this is I1. So I can say what? I2 greater than I1. Okay. All these So here they have given also I3, I2, I1. So here saturation current more, all is started from the same point, means energy of photon is same. Energy of photon is same, then it means here intensity more, here intensity less, here intensity less. So I3 greater than I2 greater than I1. Okay. Second thing, kinetic energy will depends upon which factor. So here number will not decide the kinetic energy. How electrons are ejecting due to the photon. So suppose we are saying the photon energy is the 5 eV and the minimum energy required to eject from the metal surface is the 2 eV. So extra amount of energy will go in the form of kinetic energy. So kinetic energy will like frequency will decide the maximum kinetic energy of the photoelectron. Suppose I am saying the energy of photon becomes 6, same metal I am taking work function 2, then what is the maximum kinetic energy? 4. So maximum kinetic energy of the ejected photoelectron will depends upon the frequency of the photon. When we are increasing the frequency of the photon, then the maximum kinetic energy will increase. But one photon we can say it can eject maximum 1 photoelectron. Okay. So here they have given what? Now suppose I am saying I have the different energies 3 eV, 2 eV and 4 eV. There are some electrons, photoelectron have the energy 3 eV, kinetic energy 3 eV, some photoelectron has kinetic energy 2 eV and some photoelectron has kinetic energy 4 eV. If I want to stop, to whom I will stop so that every electron will get stopped? If I will stop the maximum kinetic energy photon, maximum kinetic energy photoelectron. So if I stop this, so this and this will also get stopped. So what is the potential I will give to the collector? Minus 4 volt. Minus 4 volt, then what is the work done by the potential QV? QV means minus 4 EV. Minus 4 EV and this 4 eV, then energy become 0, then it will stop, then it will also stop, it will also stop. So what is the stopping potential for these energies? I can say stopping potential is what? Minus 4 volt. So stopping potential depends upon which factor? It depends upon the maximum kinetic energy. So maximum kinetic energy is the 4 eV, that's why stopping potential we are getting minus 4 volt. So that's why here written also K max is equal to E into V naught, where V naught is the stopping potential. So basically when we are writing the K max is equal to EV naught, we have to write the magnitude of stopping potential. The stopping potential is negative. Suppose I am saying stopping potential is minus 4 volt. I will not write K max is the minus 4 EV. I will write K max is equal to 4 EV. So basically that we are writing the magnitude of stopping potential. Okay. Now this one thing here, it is given thus for a given frequency of incident radiation. Given frequency means energy of photon is constant. The stopping potential is independent of intensity. Stopping potential is independent of intensity. Given energy means energy of photon is constant. Now when we are changing the intensity means we are changing the number only. We are not changing the energy of photon. So then stopping potential depends upon the K max and K max depends upon the energy of photon. So when I am saying the energy of photon is constant, then K max is constant. K max is constant, then the stopping potential will be constant. So stopping potential doesn't depend upon number. That's why they are saying here, given frequency of incident radiation, the stopping potential is independent of its intensity. In other words, the maximum kinetic energy of photoelectron depends upon the light source and the emitter plate material. Maximum kinetic energy depends upon the light source and emitter plate material, but it is independent of intensity. It means maximum kinetic energy depends upon the work function. Maximum kinetic energy depends upon the work function and energy of photon. It will not depends upon the number. It will not depends upon the number. What I said, like suppose energy of photon I am taking 5. 2 metal I am taking, one has the work function 2 eV, one has the work function 3 eV. So energy of photon is 5. So one case maximum kinetic energy I will get 2. One case maximum kinetic energy I will get 3. So now you can see maximum kinetic energy depends upon the work function. Now same metal I am taking whose work function is 2 eV. But I am taking the two different photons 6 eV and 5 eV. So 5 eV work function 2 eV. What is the K max? 3 eV. 6 eV work function is 2 eV. What is the K max? 4 eV. Now one case I got the K max 3. One case I got the K max 4. So that's why they are saying K max depends upon work function and the energy of the photon. It doesn't depends upon the number. Okay. Now here you can see also this graph. Here in this graph what they are showing, when frequency more, maximum kinetic energy more. Maximum kinetic energy more, stopping potential will be more negative. So like here, this graph is plotted for different frequencies, nu3, nu2, nu1. Now for nu3, we require more negative potential to stop. For nu2 lesser, for nu1 lesser. Okay, so it means I can say here which frequency is maximum in this graph. So nu3 more than nu2 more than nu1. Everybody got or not? Why? The stopping potential or maximum kinetic energy depends upon the energy of photon. It doesn't depend upon the number. Okay, so here I can say for nu3 we require more negative potential to stop. That's why nu3 greater than nu2 greater than nu1. Okay. Now this graph we plotted by the Einstein equation, also photoelectric equation. Everybody know energy of photon, that is equal to what? Work function plus K max. Okay, this is the Einstein equation, or we can say energy of photon is what? H nu. Work function I can write as a H nu naught, where nu naught is the threshold frequency. K max we can write E mod Vs. E mod Vs. Suppose I need the graph between the stopping potential magnitude and the frequency. That graph they plotted here. Frequency of incident radiation and stopping potential. So basically it is a magnitude of stopping potential. So stopping potential we are plotting on y-axis. So this is the y, E, H nu naught, or directly you can write as a work function. Nu I am plotting, frequency I am plotting on x-axis, so hx. Now y is equal to what? You will get what? Y is equal to h upon Ex minus h nu naught, or directly I can say W by E. Y is equal to mx plus c. This is a straight line with y-intercept is negative. What is the y-intercept in that? Minus of W by E. So y-intercept is the minus W by E. What is the slope? H by E. So slope for all metal is constant, because H is the Planck constant, E is the electronic charge, that is a constant. So here for any metal, when we are plotting the graph between the stopping potential and the frequency, slope will be constant. That's why all lines are parallel to each other. Metal A and metal B, they are parallel to each other. Everybody got? So here slopes are all the slope, where whatever the metal you are taking, we will get the parallel straight line. Okay. Whose work function is more, that negative intercept will be more. Like metal B, y-intercept will be more negative. Metal B, y-intercept will be more negative. Then I can say metal B has a more work function. Metal B has a more work function. Another way also we can calculate the work function. X-intercept is the threshold frequency. X-intercept is the threshold frequency. Whose X-intercept is more, its threshold frequency more. Threshold frequency more, work function more. So either I can compare the work function by X-intercept or by Y-intercept. Whose X-intercept more, threshold frequency more. Threshold frequency more, work function more. Or Y-intercept is what? Minus W by E. Whose Y-intercept is more, its work function is more. But slope for all the metal will be same. That slope will be equal to H by E. Why this experiment verify the particle nature? So that here it is given also, because if it is a wave nature, then whatever the frequency we are taking, it doesn't matter. All radiation has to eject the photoelectron. Maybe they will take more time, but ultimately ejection has to take place. But what we observe in this, when the energy of photon is less than the particular energy, then whatever the time you expose the metal with the light, then no ejection will take place. But when the energy of the photon is sufficient or more than the threshold energy, immediately ejection is taking place, means without the time span, means time span is around 10 to the power minus 9 seconds or less. Also it is given here. The photoelectron electric emission is an instantaneous process without any apparent time lag. It is nearly equal to 10 to the power minus 9 seconds or less. So here immediately it is ejecting. If it is a wave nature, it will take some time to absorb the sufficient energy, then it will come out. But when the energy of photon is sufficient, immediately it is coming out. So due to this, we can say here this experiment verify the particle nature. Okay. Second thing, one important thing is there. This is the Einstein equation. Einstein equation question already you will do. So this is the directly based on the Einstein equation. One thing, energy of photon, we are using the relation what? For the energy of photon, if you know the wavelength in the angstrom, so energy of the photon we are saying EPH is equal to 12,400 upon lambda in the angstrom. Okay, then energy directly you will get in EV. This formula everybody know. So if we want to, we will not calculate SC by lambda, then we will calculate in the EV directly 12,400 upon lambda. Lambda you will put in angstrom, then directly energy you will get in EV. Okay. One thing here also given. So by which factor or the quantity we are able to say that this experiment we can explain from the particle nature only. So here it has given that I said in the class also. Observation on the stopping potential, its independence of the intensity and dependence on the frequency. Observation on the stopping potential, its independence of intensity means it doesn't depends upon the number, and dependence on frequency means the stopping potential depends on the frequency, are the crucial discriminator between the wave picture and the photon picture of. Okay, so means suppose they given this statement, means who is the crucial discriminator between the wave picture and the photon picture. So what is the what? Stopping potential, it doesn't depends upon the intensity. Means if it depends upon the intensity, means whatever the light energy we are taking, ejection will take place, and then accordingly stopping potential will depends upon how much time light exposure take place. But here what is happening? Stopping potential doesn't depends upon that. Stopping potential directly depends upon what? Energy of the photon. So that's why it has given here observation on the stopping potential, its independence of intensity, means it doesn't depends upon intensity, but it depends upon the frequency, are the crucial discriminator between the wave picture and photon picture. Okay. Now de Broglie hypothesis, everybody know, like matter has the dual matter moving particle moving mass, we can associate a wave. That wave is called the matter wave. And what is the de Broglie wavelength of the matter wave? Lambda is equal to h by p. P is the under root 2 mk. P is equal to k. We can reuse the q into v. So many formulas are there for the de Broglie. All we have learned in the energy and momentum. But for photon, only one difference is there. We can use the same formula for the photon, but for the photon, we are not using P is equal to under root 2 mk. For any particle, we are using P is equal to under root 2 mk, but for photon, we cannot write this. Why? For the photon, we are not writing energy K is equal to half mv square. For photon only, what we are writing, lambda is equal to h by p. P we are writing as a E by C. Only this is the difference. Otherwise, this formula we can use for the photon also. Okay. This also one thing I said in the class here. One statement given: a photocell is the technological application of the photoelectric effect. It is a device whose electrical property are affected by light. It is also sometimes called an electric eye. I said this is a good question for the assertion reason. Why the photocell is called the electric eye? Because its electrical property are affected by the light. Okay. Now de Broglie wavelength, like suppose lambda is equal to h by p. When we are taking the mass is large, like we are moving, I am moving, so I can associate the de Broglie wavelength with me also. But why it is difficult to detect? Because my mass is more. So for very small particle, lambda will be more. Very small particle, lambda will be more. So we can easily detect the de Broglie wave or wave. But for the heavier mass, we cannot detect. Okay. So like in the they ask this question: electron, positron they given, and the dust particle they given. In which case it is difficult to detect the de Broglie. So dust particle, because dust particle mass is more. Okay. Then question all you will solve from NCERT. Here in that case, already all concept here I discussed. Any particular problem that you have to solve? No. Okay, so whatever you have solved in that you can. So basic simple problems are there. Okay. If you have the time, then you can go to the NCERT exercise problem. Otherwise, not required. Whatever you have solved, it is sufficient. Okay. Now, next chapter is what? Atom also first we can complete. In atom, first, that is a Thomson model. Thomson model is what? Plum pudding model or the watermelon. One thing why the Thomson model got rejected. So Thomson, what he said, like in the watermelon, like a seeds, electrons are embedded in the positive charge. So why the Thomson model got rejected? One thing we have to remember, on the basis of the electrostatic stability, Thomson model got rejected. Why? In the positive charge space, electrons are embedded. So on the electron, net force will not be zero, because suppose I am taking the this is a watermelon. Suppose I am taking any seed like this. So surrounding positive charges are there. So this, like on the electron, if you see this side positive charges are there, this side positive charges are there, this side more positive charge, so it will experience net more force in this direction. And this side less positive charge, it will experience less force in this direction. So on the electron, net force will not be zero. So then how in the watermelon, we know that seeds are at rest. Seeds are not moving inside the watermelon. Okay. But if we are taking the seed as an electron and this red, it is as a positive charge. So on the electron, any electron, we can say net force on the electron will not be zero. So on the basis of electrostatic, then Thomson model got rejected. So on the basis of electrostatic stability, Thomson model got rejected. Why? Because according to his model, net force on the electron will not be zero. Okay. Then Rutherford has done the experiment, Rutherford alpha scattering experiment. In that, what he observed, most of the alpha particle goes undeviated. Then he concluded what? Most of the part of the atom is the what? Void, means massive, very less alpha particle is got what? They retrace their path. So he concluded what? In the nucleus, we have the very massive part is very small, and it has the positive charge because they are coming back. So most of the alpha particle got what? They pass undeviated. So deviation angle and the number of alpha particles, that reverse relation is there. This relation, we know that n is inversely proportional to sine to the power 4 theta by 2, where theta is the scattering angle. Okay, so more angle, then the less number of the alpha particle we will get at that angle. Okay, so that's why what will be the graph between the number of alpha particles scattered and the theta. This is like a hyperbolic type graph we will come. So scattering angle, when the scattering angle is increasing, number of alpha particle is scattered at that angle will decrease. That's why this graph we will get. Okay. And in whole atom, in the chemistry also we have done the revision of the atom. In physics, mainly in atom, what they are giving, whatever they are giving in the chemistry, like they are changing. Like all formula we derive, we mucked up the formula for the radius of the nth orbit, we have mucked up the energy of the nth orbit. But we have to know that how we got the formula. So here we required how we got the formula of the radius of the nth orbit or energy of the nth orbit. Why? They are changing the atom, hypothetical atom. Last year also they asked the same question. So they are changing the force equation and they are asking how the radius will depends upon the n, how the energy will depends upon the n. So all formula we derive by using the two relation. One is what? Force is equal to centripetal mv square by R 1. Second Bohr quantization MVR is equal to NH upon 2 pi. These two we are using to derive all relation. Okay, so means in the actual atom electrostatic force is the centripetal, so we are taking 1 by 4 pi epsilon naught Z E square by R square is the mv square by R, and the Bohr quantization MVR is equal to NH upon 2 pi. So two variables we have, V and R. We are finding the one variable like V from the, suppose this equation, we will put in the first equation, you will get the R. After getting the R, you can get the V. By this way, we can find the energy, we can find the radius dependence, how they depends upon the N value. Okay, like last year, one question they said force is constant. Force is constant, then how the radius will depends upon the N. So force constant means I can say V square is directly proportional to R. So V directly proportional to root R. V directly proportional to root R, then here I can replace this V with root R into R directly proportional to N. From that we can find the R dependence. Okay, everybody got or not? Okay, if so here last year also one question they given in the moving charges and magnetism, that question they given. They are saying magnetic field in the atom is B, electron is moving due to the magnetic field. In that case electrostatic force, what we will write? QVB. QVB means EVB. So then EVB will be equal to mv square by R. So ultimately in the atom we are using these two. If the Bohr quantization, they are saying Bohr quantization applicable, then we will take MVR is equal to NH upon 2 pi. But if they are not saying, they are saying only the force equation, then like that we can do force equation, we will equate force will be equal to the centripetal. Everybody got? By using these two we can derive any relation, any dependence. Okay. So like here electrostatic force is the mv square by R. From that we got the R value. Then half mv square is the energy. Energy, by putting the V we are getting the energy formula also. Okay. Lyman-Balmer Paschen-Bracker series, all everybody know, means we have to know the minimum number of minimum orbit for the Lyman series is the 1, for Balmer is equal to 2. And I said what, like one PACE exam we gave the question also, means there is a no overlapping in the wavelength in the Lyman and Balmer series. So wavelength, we cannot mug up all the wavelength of Lyman and Balmer, but one thing we know that we can relate with the energy very easily. Like if I'm asking, in hydrogen atom, what is the minimum energy of photon we can get? In Lyman series, in hydrogen atom, what is the minimum energy of photon we can get? So that is a 10.2. Why? Because first and second orbit, what is the energy difference? 10.2. Energy difference between first orbit and second orbit is 10.2. So minimum energy photon in Lyman series, what I can get? 10.2. What is the maximum energy photon in the Balmer series? So Balmer series means lower shell is 2. Okay, maximum energy if I am saying, so infinity to 2, infinity to 2. What is the difference? 3.4. Okay, minimum energy if I am saying in the Balmer series, so 3 to 2. 3 to 2 means second orbit energy 3 minus 3.4, third orbit energy is the minus 1.5, difference will come 1.9. So minimum energy photon in Balmer is 1.9. Maximum energy photon in Balmer is 3.4. I am talking about hydrogen atom. Everybody getting or not? So minimum energy in the Balmer series is 1.9, maximum energy is the 3.4. What is the minimum energy in Lyman? Minimum energy in Lyman is 10.2. So minimum energy of Lyman is more than the maximum energy of Balmer. So it means any energy photon can be equal in the Lyman and Balmer. No. Why? Balmer maximum is 3.4 and Lyman minimum is what? 10.2. So no any energy of the photon can be equal in Lyman and Balmer. It means energy not equal, so 12,400 upon energy in EV. Then you will get the lambda in angstrom. How the lambda can be equal? So no any wavelength can overlap. Means the wavelength of the all wavelength of the Lyman and Balmer will be different. Understood or not? So if you are directly unable to relate with the wavelength, you can relate with the energy, because ultimately a spectral line is what? That is a photon. Okay. So like by using this radius and all, they have derived by Bohr quantization MVR is equal to NH upon 2 pi, and then force equation, we are getting the velocity relation, we are getting the radius relation. Okay, energy formula already you mugged up in the EV, in the joule also you mugged up. energy level also, you have to remember the difference between the first orbit, second orbit, first orbit, third orbit. Okay, if it is a hydrogen atom, then it is okay. Hydrogen like atom, then you have to multiply with Z square. That also you have to do. Okay. So here all that is all like all you know. De Broglie hypothesis means what? The orbit circumference of the electron orbit means that is a 2 pi r. 2 pi r is equal to n lambda. This also directly you have to remember if they are asking the what is the wavelength of the electron in the third orbit if the radius they given. So then you will think that lambda is equal to h upon mv we have to use. Then you have to find the velocity in the third orbit, not required. If radius given, so circumference is equal to the n lambda. So like third orbit I gave and I gave the radius of the third orbit. So 2 pi r is equal to 3 into lambda. So I will directly get the wavelength of electron in the third orbit. Okay. So in this question, which question means like all we have done in the class, but question number 12.9 that you if you want then again we can do 12.9 and rest directly that is based on the simple radius formula and all. So 12.9, 12.4, okay. These you can do because most of the question you have done similar question in the chemistry also. So 12.9 and 12.3 again you will solve, okay. Okay, then now 2-3 chapters remain. Now wait for that 5 minutes. Okay. So up to the 130 I can go. So now 3 chapters are remaining: ray optics, wave optics and semiconductor, which I have to discuss. If any particular chapter you want, then it is okay. Ray optics, wave optics, anybody will suggest, or you are going for the lunch? Lagging. Okay, so semiconductor polarization. Okay, so mainly wave optics and semiconductor. Okay, first I am going through the semiconductor fast without solving any question, just because it is a theoretical chapter also. So here one thing, they will not ask this because it is a like directly mugging. What is the range of the resistivity for the metal, semiconductor and insulator? For metal, it is a 10 to the power minus 2 to the 10 to the power minus 8 ohm meter. For semiconductor, 10 to the power minus 5 to 10 to the power 6 ohm meter. Resistivity will be maximum for the insulator. So that order is what? 10 to the power 11 to the 10 to the power 19. So just see this order because they will never ask, but maybe. So due to that, just you have to remember the order of the resistivity of the metal, semiconductor, and minimum for the metal and maximum for the semiconductor. Okay. Semiconductor is what? Their conductivity is more than the insulator and less than less than the conductor. And basically we are saying that there are two type of semiconductor. One is the elementary, one is the compound. Elementary means we are in the whole chapter we are talking about the germanium and silicon. They are the elementary semiconductor. And one is the what? One is the compound semiconductor. Now compound is also two type, inorganic and organic. So inorganic semiconductor means inorganic compound like gallium, arsenic, CDS, CDSE. These are the inorganic semiconductor. And organic polymer like organic anthracene, all are the organic semiconductor. So on the basis of the like compound, we can divide into the two type, inorganic semiconductor and organic semiconductor. And another one is what? Elementary semiconductor. That is the pure element. It is a silicon and germanium. Okay. Now energy band. What is the meaning of energy band? So energy band is what? Suppose we are taking one particular one electron only. So one electron will have some energy. We can define its energy. Well-defined energy it will have. Maybe we can say this is the kinetic energy of electron. But suppose when we are taking the crystal, in the crystal we have large number of atoms. A large number of, so Pauli exclusion principle also we have learned what in the atom no any two electron will have same energy, means all the electron will have the different energy in the atom. Okay, so suppose I am taking the example of the sodium atom. So sodium atom 11 electrons are there, all 11 electron will have different energy. Okay, suppose I am talking about the valence electron. So in the sodium how many valence electron are there? 1. Okay, but if I am taking sodium crystal, there is a n number of the sodium atoms are there. So each atom is interacting with the other atom. Okay, so each atom electron, they are interacting with a different electron. Okay, all electron will have the same interaction, equal interaction. That is not possible. So what will happen in the crystal? Suppose I am saying I have the n sodium atom in the crystal. So in the n sodium atom, we will have the n valence electron. Then n valence electron all will have same energy. No, why? Different valence electron are interacting with a different atom. So all interactions are not equal. So that's why, like suppose in the classroom, who is suppose students are sitting, who is in the mid, they are interacting more student. Who is sitting near the wall, they have the less interaction because they are the one side no force is there due to the student. Like that we can think in the crystal all electron will not interact equally. So that's why electrons will have the different energies. So that's why we are defining here energy band, means it is a range of the energy. Valence electron also, n valence electron we have, n valence electron will not have equal energies. So they will have the different energies. That's why we are defining the energy band, means it is the range of the energy. So which contain the valence electron, that is the valence band, and higher energy band, like in the sodium 1s2, 2s2, 2p6, 3s1, then we will have the fourth orbit, third orbit, higher orbit also there. So those vacant energy band or higher energy band is called conduction band. Okay, so the energy band means that is the range of the energy, that is called the energy band, which contain the valence electron, it is a valence band, and which contain the free electron or the conduction electron, that is called the conduction band. Conduction band is the higher energy band. Okay, this has given here. Now, one thing we are defining the band gap. Band gap means what? Like suppose this is the valence band that contains the valence electron. Higher energy band is the conduction band. So top of the valence band and bottom of the conduction band, that is called the energy. This difference is called the energy gap or forbidden gap. Okay. Okay. So what is the energy gap or forbidden gap? It is the energy difference between the top of the valence band and bottom of the this is the conduction band. Bottom of the conduction band. Okay, so minimum energy required, or another way we can say minimum energy required for the valence electron to go to the conduction band is called the energy gap. Minimum energy from here to here. So minimum energy required for the valence electron to jump to the conduction band, it is called the energy gap. Okay. Common sense, energy gap will be minimum for the conductors or the metal and maximum for the insulator. So that energy diagram also given, band diagram, this. Like here, greater than 3 electron volt if the energy gap, then it is the insulator. Less than 3 electron volt, then we are saying the semiconductor. Overlapping conduction band means energy gap is nearly 0, then that we are saying the conductor. Okay, so for the conductor we can say energy gap is very small, or energy gap is 0 because conduction band and valence band are overlapping. Like the sodium example of the sodium. Sodium we have 3s1. So in the 3s even we have the energy state is free in which electron can conduct. So it means in the sodium valence band and conduction band are overlapping. But in the zinc they are different, but the energy difference will be very small. So in the metal we can say the energy gap is nearly 0 or it is a very small. In the insulator it is greater than 3 electron volt according to the NCERT, and less than 3 electron we can say it is for semiconductor. Okay. Intrinsic semiconductor means what? Pure semiconductor. Pure semiconductor we are calling as an intrinsic semiconductor, like pure germanium, pure silicon. So they are the intrinsic semiconductor. At 0 Kelvin we are taking what? There is a no free electron in the conduction band. There is a no electron in the conduction band. So at 0 Kelvin semiconductor will behave like, intrinsic semiconductor will behave like an insulator. Right? There is a no free electron is there. But at room temperature, due to some thermal energy, the electron will acquire some energy, 0 Kelvin, and room temperature means around 298 Kelvin. Means electron will acquire some electron will get the sufficient thermal energy, they will become free and they will go to the conduction band. So that's why they will have some conductivity, but that conductivity will be very low. One thing. Second thing, valence electron in the like silicon, when we are taking the example. So electrons, suppose silicon electron become free, electron covalent electron came out. So when electron came out, so what will happen in the covalent bond? We can say there is a deficiency of the electron. That deficiency is the means electron deficiency we are treating as a positive charge, that is called the hole. Hole is nothing, there is no meaning of the hole. Hole is the only the imaginary thing. Only to explain the conduction easily in the semiconductor, we introduce the concept of the hole. Hole means what? Ultimately, when we are saying hole is moving from left to right. So hole is moving from left to right, or positive charge is moving from left to right. Basically, who is moving? Electron is only moving. Okay. But hole electron, one electron is in the conduction band, one electron is moving in the valence band. So it will create the confusion. That's why we introduce the concept of the hole. So what is the hole? Hole is the deficiency of the electron, so that we are treating the covalent bond, that we are treating as a hole. Okay, hole we are treating as a positive charge. Okay, so now suppose I am saying due to the temperature, 10 electron from the covalent bond, they jump from the VB to CB. That 10 electron got the sufficient energy, they jump from the VB to CB. So 10 electron are there in the CB, then how many holes are in the VB? 10. So due to the temperature, remember that always electron and hole pair created will be equal. Always electron and hole pair will be equal. So how many electron will jump to the CB? Same hole we will get in the VB. Hole will always belongs to the VB and the free electrons will be in the CB. Okay. So what I said, due to the temperature, always electron and hole will be equal. Okay. So that they are saying in the intrinsic semiconductor, the number of free electron Ne is equal to the number of hole Nh, that is the Ne is equal to Nh is equal to Ni. So in the intrinsic they will be equal. Okay. Like that what I said, remember that the motion of the hole is only the convenient way of describing the actual motion of the bound electron. So basically what I said, hole is moving, basically electron is moving, but hole is the easy way to explain the motion. That's why we are using this word hole. Hole we are treating as a positive charge. Like here you can think, suppose electron is moving from the one side to the another side. Suppose there is a deficiency of the electron here. Now from this covalent bond, electron jump from here to here. So then I will say what? Hole goes from this side to this side. Okay. So electron move to the left, hole move to the right. So hole move to the right means it is the opposite to the electron. So basically we can say the hole is a positive charge. Hole is moving where? In the valence band. Okay. Everybody got or not? So when we are saying the hole is moving, so basically who is moving? Electron is moving in the opposite direction. Okay. Extrinsic semiconductor means what? When we are doing the doping. Doping means what? When we are adding the calculated amount of the impurity like a trivalent or pentavalent atom in the elementary semiconductor. So the conductivity will increase many times. Okay. So this doped semiconductor is the extrinsic semiconductor. We can dope the trivalent atom or the pentavalent atom. Okay. But for the doping, two things we have to take care for the doping. One, size of the dopant must be equal or comparable to the size of the semiconductor atom. Otherwise, suppose dopant size is very large, so it will disturb the whole crystal structure. So that's why dopant size and the semiconductor atom size must be equal. One thing. Second, impurity concentration should not very high. Okay, because we are adding the impurity, so ultimately the concentration has to be low. Otherwise, what will happen? We will discuss the impurity character, not the semiconductor. Okay, so that doping concentration must be low. It is the order of the ppm. Ppm means 1 parts per million. In a 1 million of the semiconductor atom, we are adding the 1 dopant. Okay, so these two things we have to remember. Size of the dopant must be comparable to the size of semiconductor atom. Second thing, doping concentration must be low. That is the order of the ppm. Okay, on that basis of the doping dopant, there are the two type of semiconductor. One is the n type, one is the p type. N type, p type we have given on the name nomenclature, we have given on the basis of the majority charge carrier. N type means majority charge carrier is electron, and the p type means majority charge carrier is the positive, means hole. Okay, when we will get the n type semiconductor? When we are doping the pentavalent atom, when we are doping pentavalent atom. And when we will get the p type semiconductor? When we are doping the trivalent atom. Okay, now n-type semiconductor, pentavalent doping is donating 1 extra electron for the conduction and is known as donor impurity. So here you can see this. In the n-type and p-type semiconductor, n-type semiconductor means majority is the electron. Why? Because suppose I added the pentavalent impurity like phosphorus, then phosphorus replace some silicon. Now suppose here phosphorus came. So phosphorus has how many electron in the outer shell? 5. But 4 covalent bonds are there. It means 1 electron is not involved in the bonding. Okay. So, but that electron is not a free electron because it is bounded with phosphorus. So its energy will be slightly less than free electron. That's why in the n-type semiconductor, we are getting the donor level below the conduction band. Why? This donor level is due to these electrons. By giving the small amount of energy, they can be free. So n-type semiconductor, we are getting the donor level. Donor level, why? Because they can give the electron. Where? To the conduction band. So we are getting the donor level very close to the conduction band in the n-type semiconductor. And p-type semiconductor, they will create the hole like aluminum if I added. So aluminum is only 3 electron in the outer shell. So 1 covalent bond will have that deficiency. So it will create the hole. So that will create the acceptor level. Hole means they can receive the electron from the VB. So acceptor level will be just above the valence band and donor level will be just below the conduction band. So n-type semiconductor we are getting donor level, p-type semiconductor we are getting acceptor level. Okay. Then one thing I said, in the intrinsic semiconductor, number of electron, free electron and number of hole are equal. Okay. But when we are making the n-type and p-type semiconductor, in the n-type semiconductor, electron density is very high in comparison to hole density, and in the p-type semiconductor, hole density is large in comparison to the p-type. Hole density is very large in comparison to electron. Okay. But how we will find the number also? Suppose I am doping and they have given the doping exact number we cannot count. So all formula what we have learned in this semiconductor in this topic, that is not the exact. Okay. So what we are doing here, suppose I am saying I am adding the nx number of the pentavalent atom. Okay, nx number of the pentavalent atom I am adding in the pure semiconductor. So pentavalent if I am adding, so first thing we have to know who will be the majority. Electron will be the majority. So who will be more? Electron will be more. So directly we can get electron density Ne is equal to what? Number of pentavalent atom added. How many pentavalent atom you are? How many pentavalent atom you are adding, that will be the number of electrons. So one directly we will get by the number of the impurity atom. If I'm adding the trivalent, so directly I will say NH is equal to number of trivalent atom added. Okay. Then second, how we'll find? So in the pure they will give. Suppose I have given in the pure semiconductor number of electron is equal to number of hole, that is equal to Ni. In the intrinsic semiconductor they are equal. So Ne is equal to NH is equal to Ni. That I gave. Okay, and I gave how many pentavalent atom I added. So number of electron, I will get number of pentavalent atom added. That is the first step if I'm adding pentavalent impurity. Then how I can find the NH? NH I cannot take this. Why? Because when I will add the pentavalent impurity, so electron concentration will be high. Now whatever the hole will be earlier. Now electron concentration is high, so what will happen? Some electron will fill some hole. So hole concentration will decrease. So it will not be equal to the initial hole concentration when it was pure. Why? Because of the electron density increase, some electron will fill the hole. So what will happen? The hole density will decrease. So then how we will find the hole? Then we will use this relation Ne into NH is equal to Ni square. So for any extrinsic semiconductor, electron density into hole density will be equal to Ni square. So electron I got by this relation, Ni I have given, then from this I can calculate the NH, and that NH will come less than this number. Why? Some hole will get filled by the electron. And this is called the law of mass action. This is called law of mass action. Okay, so many times we gave the question based on this relation. So one question has given here. Okay, 1 ppm, according to the ppm we can find the number of the pentavalent impurity. Then we can use the Ne into NH is equal to Ni square. Now PN junction diode. So in the PN junction, when we are one thing, P and N means one is a P-type semiconductor, one is a N-type semiconductor. But PN junction we cannot make by taking P and N and we can stick them. Okay, why? Because to stick them, they will not come in the atomic level, they will not come in the contact. So PN junction we cannot make by joining P and N semiconductor. Here also given also in one NCERT question, this. Can we take one slab of P-type semiconductor and physically join it to the another N-type semiconductor to get PN junction? No. Why? No, any slab, however flat, will have the roughness much larger than the interatomic crystal spacing 2 angstrom to the 3 angstrom, and hence continuous contact at the atomic level will not be possible. That's why we are not making the PN junction by stick the P and N. Whether you are using adhesive or you are pressing them, they will not come in the atomic level, they are not come in the completely contact. Okay, so how we are making the PN junction then? So we are taking one pure semiconductor. In that pure semiconductor, one side we will diffuse the trivalent impurity, one side we will diffuse the pentavalent impurity. Which side you are diffusing the pentavalent impurity, that side it will make the N-type. Which side you are diffusing the trivalent impurity, it will make the P-type. Like that way, one side you got N, one side you got P. And due to the concentration difference, N side electron concentration more, electron will move from N side to the P side. And P side hole concentration more, hole will move from the P side to the N side. So near the junction, the recombination, electron will fill the hole. So near the junction, we will get one layer of the immobile ion. Means why? Because N side electrons are moving to the P side. Okay, holes are moving from P side to the N side. Near the junction, electron fill the hole. Electron fill the hole, then what will happen? Suppose holes are moving this side, electrons are moving this side. So near the junction, what will happen? Electron fill the hole. Electron fill the hole. So earlier they were neutral. N-type semiconductor is neutral, P-type semiconductor is neutral. Majority is the electron and hole. But ultimately, we added the neutral atom in the neutral atom. So crystal is neutral. We are calling as N-type semiconductor. Why? Because majority is the electron, but excess electron is not there. So crystal is what? Neutral. So N-type semiconductor, P-type semiconductor, crystal is neutral. Okay. So then suppose this electron, phosphorus release this electron. So phosphorus will become P plus. Al receive the electron, it become Al minus. It means earlier they were neutral, but when the electron fill the hole, that phosphorus atom become positive charge. So on the N side we will get positive charge. And who received the electron? Which hole received the electron? We will get the negative charge. So near the junction, we will get the layer of the, these are the ion. This plus is not the hole. This plus is what? The phosphorus atom who has given the electron. This negative is what? Aluminium atom who received the electron. So near the junction, we got the layer of the immobile ion, that is called what? Depletion layer. Depletion layer. Okay. And in the depletion layer, you can see one side we are getting positive, one side we are getting negative. One more thing, we are representing like a capacitor, like positive are in the one line, negative are in the one line, but that will not be the like a straight line, because they will not get the holes in the straight line. Some hole will get filled here, some hole will get filled here. So like randomly distribution will be there. We cannot say like electric field between the in the depletion layer will be constant. Okay. We are representing like this way, but some electron here, some hole here, some hole will get filled here. So distribution will not be the uniform. Okay. This layer of immobile ion is called what? Depletion layer. Now you can see positive charge we are getting N side, negative charge we are getting P side. So internal field also developed. The direction of the internal field is from N to P. Which side we are getting higher potential? N side we are getting higher potential, P side we are getting lower potential. That's why here it is showing also. Diode under equilibrium, V is equal to 0. Barrier potential under no bias. No bias means we have not connected any battery. Which side we have high potential? N side. Which side we have the low potential? P side. And this represents the barrier height. Barrier height, why? Because this electric field will oppose the majority. Why? Electric field is developed in this direction. Now electron was going from N to P, hole was going from P to N. So this electric field will apply the force on the hole in this direction. Okay. And electric field will apply the force on this electron in this direction. So what will happen? This internal field will oppose the majority charge carrier. That's why this field, that is called the barrier potential. The potential developed in the depletion layer is called barrier potential or the junction potential. Okay. Because they are opposing the majority. But P side, who is the minority? Electrons are minority in the P side. Who is the minority in the N side holes? You can see this electric field will apply the force on this hole in this direction and electron in this direction. So it will promote the minority. It will oppose the majority, but it will promote the minority. So as the electric field will start developing, majority will oppose, minority will promote. So due to the minority or electric current is flowing due to the electric field, that current is called drift current. Drift current. What is the direction of the drift current? N to P. Direction of drift current is from N to P, and it is due to the internal field. Okay. And what is the direction of the diffusion current? That is due to the majority. It is from P to N. So these are the small questions they can ask. What is the direction of the diffusion current? P to N. What is the direction of the drift current? N to P. So all this has given here also. Okay, so like here hole diffusion, here hole drift and hole diffusion. Drift means what? It is due to the, why it is called the drifting? Because it is due to the internal field. So that's why we are calling as a drifting. Diffusion is due to the concentration difference. Diffusion current flows from P to N due to the majority. Drift current flows from N to P due to minority. Okay. Now here PN junction diode under forward bias and reverse bias. Forward bias means what? When P is connected at high potential relative to the N, then that biasing, that is called the, that connection is called the forward bias. So with no bias, unbiased means no battery connected. When no battery connected, if I am saying what is the direction of the current in the PN junction? So without battery, there is a no current. This what I explained, like diffusion current is flowing from P to N, drift current is flowing from N to P. That is only for the, at the time of formation. When we are making the PN junction or diode we are making, that time diffusion current flows from P to N, drift current flows from N to P. But when our diode will form, then if I am asking what is the current in the diode, then it is zero. Why? In the equilibrium, drift current and diffusion current will be equal. Okay, so without biasing, what will happen? At the time of formation, majority will flow. Due to the majority flow, what will happen? Field will develop. Due to the field, drifting will start. But after some time, what will happen? Diffusion current and drift current will be equal. So what is the current in the PN junction? 0. So when we are saying there is a no battery connected, what is the current in the diode? 0. So in the JMIN also they ask this question, one conducting wire is connected with the PN junction diode. What is the direction of the current in the conducting wire? There will be no current. Why? Without battery, current will not be there. We will say that diffusion will flow from P to N, drift will flow from N to P. Why? When the PN junction form, all happened earlier when we were making the PN junction, but our PN junction form, then there is a no current without the battery. Okay. So forward bias means what? We are connecting the P side at higher potential and N side at lower potential. When we are connecting the P side at higher potential, then what will happen? Higher potential means P side is at higher potential. Then what will happen? Here this P, whole are here majority, here electrons are the majority. So then due to the external field is what this, due to the internal field is here. So this external field will oppose the internal field, and what will happen? If this field is stronger enough, then what will happen? Majority will flow. Due to this external field, hole will go this side, electron will go this side. Hole is going from P to N, electron is going from N to P. So what is the direction of current? P to N. So in the forward biasing, current flows due to the majority charge carrier. What is the direction of current? P to N. And the order of the current is the milliampere. In the forward bias, we can say majority are flowing. That's why the resistance of the diode is very small. Ideal diode in the forward bias resistance will be 0. All these points you have to remember. Okay. Then here, if I am saying barrier is the V0, barrier potential is the V0, and external potential, forward potential, I apply V. What is the junction potential in the forward bias? I can say V0 minus V, V0 minus V. Okay, so in the forward bias, barrier height decreases. Why? Internal field and external field are in the opposite direction. That's why in the forward bias, barrier height decreases. That here they are showing also. Okay, first I will go to the reverse bias also. Reverse bias, what will happen? This polarity will get reversed. PR we are connecting at low potential and we are connecting at higher potential. Then what will happen? This external field is in this direction and internal field is also in the same direction. Means what will happen? Majority will oppose. Only minority will flow, and minority concentration is very less. So that's why current will be very small. It is order of the microampere. And minority concentration is very less. So even we are applying the very high reverse potential also, like we are increasing the reverse potential. But due to the low minority carrier, current will not change significantly, or we can say current is almost constant. That's why up to the certain reverse potential, current is independent of the reverse potential. So this current is called reverse saturation current. So then in that case, if the barrier junction is the V0 and the applied potential is V, what is the barrier potential? V0 plus V. So in the case of reverse biasing, barrier height increases. So in this graph, they have shown also 1, 2, 3. 1, 2, 3, they have related what? Low reverse bias, high reverse bias, and unbiased. So barrier height is minimum for the forward biasing and the maximum for the reverse biasing. I am saying low FB, high FB, and UB, unbiased. So more height for unbiased means 1 I can say unbiased, 2 I can say low FB, 3 I can say high FB. Why? Barrier height is minimum. Like that way we can relate in the case of unbiased, reverse bias, and forward bias also. Okay. So this is also the reverse bias, all this point also. Now here you can see reverse bias, barrier height increases. Okay. PN junction diode, it does not obey the Ohm's law, means V is not directly proportional to I. That's why diode is called the non-ohmic conductor. This VI characteristic curve everybody know. Here, when we are applying the forward potential up to the certain potential, current does not start flowing. Current is almost 0. So that potential is called what? Because to flow the current, forward potential has to cross the barrier. After the barrier, the current will start flowing. Suppose barrier is the 0.6 volt. Then to flow the current, applied potential must be more than 0.6 volt. Okay. So minimum forward potential for which current will start increasing exponential or current will start flowing through the diode, that potential is called knee potential or the threshold potential. Here it is showing like this. So 0.6 is the threshold potential for this diode. Why? After the 0.6 current start increasing, but up to the 0.6 current is almost zero. Okay. So this is the forward biasing. Forward biasing we are making in the first quadrant. Reverse biasing we are making in the third quadrant, and unbiased is allotted for the fourth quadrant. Unbiased we are making in the fourth quadrant. Okay. This everybody got. So here after the 0.6 volt or threshold potential, current will start increasing significantly, and here VI graph is not a straight line, that's why it is a non-ohmic conductor. In reverse bias you can see when we are increasing even the reverse potential, current does not increase significantly. You can see current is almost constant. That's why I said up to the some certain reverse potential, current is almost independent of the reverse potential. This current is called reverse saturation current. After that, breakdown will happen. What is the breakdown? In the reverse bias, when the applied potential will be equal to the breakdown potential, then what will happen? Large number of the charge carrier will produce and they will move in the direction of the minority. So that's why large current will flow. That condition is called the breakdown. So up to the particular reverse potential, reverse current is almost independent of the reverse potential. So that is called the reverse saturation current. But at particular reverse voltage, a large range of current can flow through the diode. That voltage is called the breakdown voltage. Okay. So here this shows what here between 80 and 100 we are getting, this is the breakdown voltage. At the breakdown we can have the large range of current. Okay. But before the breakdown, current is almost zero or independent of the reverse potential. Now the same here also, it is a non-ohmic conductor, so we cannot find a resistance of the conductor R is equal to V by I. So that's why we are defining the dynamic resistance in the case of the diode. What is the dynamic resistance? R is equal to delta V by delta I. So always they will give the nearby range also. Suppose they are asking at this potential what is the dynamic resistance, so they will give some nearby value. Like here if I'm asking what is the dynamic resistance when the potential is 0.5 volt, so nearby value they will give. We can take for a small range, this graph is a straight line, then we can find delta V by delta I. So what is the delta V? Like suppose these two values they given nearby, so we will find the delta V. Correspondingly we will find the delta I value, and remember that if it is a forward bias, don't forget to multiply with milli. Milli means 10 to the power minus 3 you have to take for the delta I. And if it is in the reverse bias, here it is a micro, so then you will take the 10 to the power minus 6. By the delta V by delta I, we can find the dynamic resistance in that range. So when they are asking the dynamic resistance at a particular voltage, so they will give the nearby value. Nearby value, from that you will calculate the delta V and corresponding delta I. Delta V by delta I will be the dynamic resistance. Application of diode as a rectifier. What is a rectifier? Rectifier is what? Conversion of the alternating to the direct, we can say AC into DC, that is called the rectification. We can use the diode for the rectification purpose. We can use one diode, then it is a half wave rectifier or full wave rectifier. So in the AC we know that alternate positive negative cycles are there. What is the meaning of alternating current? For half cycle, suppose current is flowing from A to B, so next half cycle current will flow from B to A. So current is a bidirectional. That is the current is changing the direction after the regular interval of time. Then that current is called the alternating current in the simple way we can say. Or the voltage is changing the polarity, then that is the alternating. Direct means what? Current will flow in a unidirection. So diode we can use as a rectifier, means to convert the AC into the DC. So half wave rectifier means only for the half cycle we are getting the current, and for the half cycle we are not getting the current. So here this is the diode as a rectifier. We are taking the rectifier circuit, one diode we are using. So for the one cycle, diode will be the half cycle, diode will be the forward bias, it will conduct the current. For next cycle, diode will be in the reverse bias, it will not conduct the current. So like that we will get the only positive, only half cycle we will get the current. But one thing in this, in between some line somewhere they given also, in the rectifier, while selecting the diode, we have to select the diode whose breakdown potential must be large in comparison to the peak applied voltage. The statement is lengthy. Again, I am repeating. In the rectifier circuit, we are selecting the diode whose breakdown voltage, breakdown always we are getting in the reverse bias. So whose breakdown voltage must be larger than the peak inverse voltage. What is the meaning? Why we are saying this? So in the rectification, what we are getting, like for half wave, first positive cycle, suppose this is in the forward bias, current is conducting, current is going from X to Y. Okay. Next cycle, what will happen? This is negative, means P is at low potential. P is at low potential, then this diode will be in the reverse bias. It will not conduct. So from the XY, I will not get the current. So we got the current for half cycle, then we are not getting current. Then again we got the current cycle, then we are not getting. So like current is flowing only in one direction, but only for half cycle. That is called the half wave rectification. But what I am saying, we are selecting the diode whose breakdown potential must be large in comparison to the peak inverse voltage. Why? Suppose this diode breakdown voltage is 5 volt and inverse peak voltage we are getting up to the 6 volt. So what will happen when we are applying the reverse bias? Reverse bias, we are not getting the current. That's why we are saying only half wave will get rectified. But we are saying it is a rectification. Why? Because current is flowing only in one direction. But suppose half negative half cycle, peak value is the 6 volt. But here breakdown voltage is 5 volt. So when peak in reverse cycle, negative cycle, when the voltage will reach up at 5 volt, then what will happen? This diode will get breakdown. When the breakdown happen, it can conduct the large amount of current. Then current we will get in the negative cycle also. So our purpose will not get solved. Our purpose is what? We want to get the DC, means we want the current only in one direction. But when we are taking the diode, breakdown potential is less than peak inverse voltage. So in the reverse bias also, diode will conduct the current due to the breakdown. Then what will happen? Through the load, we will get the current in the both direction. So again, the problem will be remain as it is. The current will not get rectified. That's why I said we are selecting the diode whose breakdown voltage must be large in comparison to the peak reverse voltage. Suppose the breakdown voltage is 10, but maximum peak reverse voltage we are getting 4. So reverse voltage will go maximum up to the 4, but diode will get breakdown at 10. So diode will not get the breakdown. So reverse current will be almost 0. So then our purpose will get solved. Okay. In the half wave rectifier, we have to remember what? Frequency of input. This is the like one cycle of the input, and this is the one cycle of the output. You can see time period is same, so frequency also same. So in the half wave rectification, frequency of input and frequency of output are equal. Okay. In full wave rectifier, we are using the center tap transformer because we have to divide the, basically we have to get the complete circuit for the current flow. Like we are using the center tap transformer. Now for one cycle, suppose this is the input of the input cycle of the A. So A is getting positive cycle, so this will be in the forward bias. It will conduct the current will go from X to Y, and then current will flow like this. Okay. Then next cycle, what will happen? Diode D2 will get the what? This is when it is getting A is getting positive cycle, then D2 is getting negative cycle. So D2 will be in the reverse bias. It will not conduct. So current will flow due to the D1. Next time what will happen? D1 will get negative cycle, D2 will get positive cycle. If the D2 is getting positive cycle, so this will be in the forward bias. Then current will flow from here and then X to Y. So we are getting the load current always from X to Y. First half I got due to the D1, then due to D2, then D1, D2, like alternately they will work. Okay. So in this case, we got the full wave rectification. Okay. But the problem is what? When we are saying the DC, so DC means the output is what? Constant. Magnitude has to be constant, because in a whole current electricity, we are taking the constant current. Okay. But here what is happening? Current is flowing in one direction, but current is what? Magnitude is changing. So that is called the AC ripple. That is called the ripples. Why? Magnitude of DC is not constant. So then in the rectifier circuit, we are using filter circuit. Filter circuit we are using to remove the ripples. So in the filter circuit, we are using capacitor. That capacitor we are connecting in parallel, or we are using inductor. That inductor we are connecting in series with the load. So again, I am repeating, full rectifier circuit output is what? We are getting DC, but that DC magnitude is not constant, it is a pulsating or it has the ripples. So to remove the ripples, what we are doing? We are using the filter circuit. Filter circuit, what is the use of the filter circuit? To remove the ripples, okay? Then in the filter circuit, what we are using? We are either using the capacitor and we are connecting parallel with the load, or we are using inductor that we are connecting in series with the load. Like this, they have given the filter circuit. This is the capacitor we connected in parallel with the load. Okay, then what will happen? Pulses will remove, then we can get this type of output. Okay, so output is almost constant. Okay, everybody got or not? So filter circuit. So why we are using filter circuit? To remove the ripples from the circuit. In the filter circuit, we can use either capacitor that we will connect in parallel with the load, or we can use inductor that will connect in the series with the load. Okay. Zener diode. Zener is what? It is working in the reverse bias only. That is a breakdown. Means basically what is the purpose of the Zener? Means we are operating in the breakdown. Okay, so Zener diode, you can see in the reverse bias, when the breakdown happen, potential does not change, but current can have any value. You can see the graph also. At reverse bias, when the breakdown occurs, then it can have the large range of current, but what is the potential? Potential is constant. So what is a Zener diode? It is a highly doped semiconductor, and that is operated in the reverse bias. In the reverse bias, when the breakdown occurs, we will adjust so that if the breakdown occurs, then diode can have the large range of current, but the potential across the diode will not change. That's why we are using the Zener diode as a voltage regulator. But breakdown we are always getting in the reverse bias. That's why Zener diode is always connected in the reverse bias. Okay. So it is operating in the breakdown region. If it is not reaching to the breakdown, then current through the diode will be approximately 0. Suppose I am saying the applied voltage is 10 volt. Breakdown voltage of the Zener is 12 volt. Then what is the current through the Zener? We can say almost 0. Why? Before the breakdown, current through the diode is what? 0. Okay. At breakdown, when the breakdown happens, then it can have the large range of current. Okay. And now suppose I am applying the 20 volt. And the breakdown voltage of Zener is 12. Now 12 is the breakdown voltage, applied is the 20. Then what will happen? This diode, Zener diode, will maintain the output voltage 12. Extra current due to the high voltage, what will happen? It will pass through the diode. So then it will maintain the output voltage. That's why we are using the Zener diode as the voltage regulator. Okay. After that, all you will revise. Now you can go for the lunch. Those two chapters, what is remaining, that I will see. Okay.